Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So good morning, everyone. Welcome. And I'd like to introduce you to our first speaker, Leslie. So Leslie, take it away.
Excellent. Thanks so much for that introduction, Johan. Good morning, everyone. My name is Leslie Hawthorne, and I am here today to talk to you about the business of community, strategic open source engagement for vertical markets. Brief about me, I am a manager of the vertical community strategy team within Red Hat's open source program office. We reside in the office of the CTO, and my team's mission is to steward Red Hat's relationship with the various organizations that relate to our verticals-based business from a community perspective. So before we get started with the meat of this presentation, I just wanted to share some parameters so we all kind of know before we go what the material for today is going to look like. First of all, you're going to hear an awful lot about Red Hat in this presentation. I promise you that this is not a series of shameless plugs, although I will tell you later that I'm hiring. That will be my one shameless plug later in this presentation. So normally I give talks that focus on community engagement and a lot of culture topics, so I don't necessarily talk a great deal about the ins and outs of my day-to-day work. But since this is about verticals community practice, and that's what I'm doing at Red Hat, you're going to hear a lot of personal examples from Red Hat and hopefully some examples from other folks that I've worked with in the community as well. We will also be exploring a great deal, but not all. Turns out the verticals universe is vast, and when Johan originally asked me to give this presentation, I thought, oh, I will cover all of the topics. And then I wrote this slide deck and thought, I will not be covering all of the topics. So we'll get to as much as we possibly can today, and I'm really happy to have follow-up conversations with folks later in social media or via email. And last but not least, I'm looking to learn. As part of giving this presentation, this is just one point of view. It's my point of view based on my own experience. If folks want to reach out and get in touch and have further discussions, I'm super open to it and excited to learn from others in the community. Maybe we start a LinkedIn group. I don't know. We'll figure it out later. So before we talk about verticals community engagement, I wanted to talk a little bit about compare and contrast between what we think of sort of as traditional community management within open source projects versus how you do this with verticals. So a traditional community management paradigm is that you have one person focused on community engagement, or many, and they're focused on that from the perspective of the project. So for example, how does the Ceph project work with other projects in achieving the mission of creating storage? Versus when you're dealing with verticals-based community engagement, you're actually looking at a whole bunch of different community interaction points, some of which overlap, some of which do not. So you may be equally excited about working with an industry consortia in order to produce a reference architecture or create a specification, and that work may never actually touch some of the software development that you're doing in a particular open source project for the same vertical. But despite the fact that there are differences in the approach, the underlying formula for success is exactly the same. You have to know your audience, you have to meet them where they are, and you need to make sure that whatever it is that you're providing within that community context provides actual value to the participants in that community, and make sure that that genuine value is as much value to the other participants as it is for your own business. So next, we'll get into the three major pillars of verticals community engagement. We're going to be talking about software projects, software foundations, and industry consortia. So if we take a view from the FSI world, specifically the financial services area, there are opportunities to work with your customers and your partners within the open source project context, and actually to do collaboration and co-creation directly in the upstream. And this is typically a wonderful vehicle for engagement for vertical markets that have a long-standing history with open source software. So the financial services folks have been using open source for a very, very long time. And now they're taking steps toward actually open sourcing software that they've created behind their own firewalls, publishing that as open source and building communities of collaboration around it. So if we look at examples like Autobahn, produced by Deutsche Bank, or Symphony, which was originally a project from Goldman Sachs. And there's an entire landscape here of projects where various engineers can collaborate and co-create with customers in the upstream. And part of the value of that is not just being able to bring a product to market, but it is deepening the value of the technology that you provide to your customer, and also deepening your business relationship through that process of collaboration and co-creation. Our next pillar is software foundations, and I've listed 3 here as examples, although there's a wide universe also of software foundations. And the value of software foundations is to create a very well understood and neutral space for collaboration. As more and more vertical market players are entering into understanding that they need to have a viable open source strategy as part of their business operations, they're getting used to this idea of co-opetition or collaborating and co-creating with their competitors, often for the first time. And by working within the context of one of these software foundations, where there are very clear rules for engagement, these foundations have bylaws, they typically have operating rules for the various technical steering committees, they have guidelines for how particular decisions are made within the project. There's, of course, a style guideline so that everyone understands what the coding conventions are for that project. By having this space created that is, again, it's a neutral home, it is a place with well understood rules, and it is a place where people can come together and collaborate on technology that is not necessarily related to their core line of business, but where they understand that by working with others in a community context, they're able to increase value for their business. Even if that value accrues to a competitor, the overall return on investment is very high because of that ability to leverage the wisdom of the crowds in this neutral community context. And our final pillar, industry consortia. So what you see here is a swath of logos for various industry consortia that work in the telecom space. I am not even going to pretend that I understand what each of these organizations do. Fortunately, I have an expert on my team who deeply understands the telco domain. We'll talk about the importance of having domain experts later on in this presentation. But the goal here of understanding the role of industry consortia is that these are groups where folks are traditionally able to come together and collaborate in highly regulated industries where they're working on technology that spans the globe, and there's a need to interoperate between various countries, various jurisdictions, understanding what the laws are for each region. And the output of these industry consortia is often the creation of standards, reference architectures, and even recommendations to public policy bodies about how to enact regulation or create laws that govern how these particular vertical markets are going to work. So now we're going to dive into the different types of approaches to verticals community engagement. And I'll give you an overview of some of the different ways in which you can conceptualize how you're engaging with vertical markets from a community perspective. So the first way that I will bring forward is this concept of the technology-led engagement. If you are interested in engaging in a particular verticals-based community because you are looking to advance the technology state of the art, right? Your ultimate goal is to either change the way something works by creating new features in a particular software project, or to bring your own expertise to market so that it it changes the way the entire industry thinks about a particular technical problem space. You're looking at a technology-led engagement strategy. And we'll get more into the meat of the resourcing aspect of this, but there are a number of companies who are excited about engaging with community from a technology leading perspective. And one of the most important things that you can do when you are looking to engage with communities to advance the technical state of the art is make sure that your resourcing strategy is well thought out and in place from day one, because it is a difficult situation when you want to advance the technical state of the art, but you just do not have enough developer resources to bring to bear to make that happen. Another way to think about your community investment strategy is from the perspective of sales leadership. So there will be any number of times when your field teams may come to you and let you know about a particular software project, software foundation, industry consortia, or other membership organization. And they will let you know that it is very important that your company joins in with this membership organization in order for the field team to close a sale, to be able to do more traditional business development activities by being able to engage with some of the influencers within that membership community. And in order to advance and influence within that particular membership body, and get the message across that your company has something of value to offer to those members. At Red Hat, we don't necessarily typically invest in membership organizations just for the sake of getting a logo on a website, but for very large organizations, there are any number of times when folks join a membership organization for the sake of showing their customers and their constituents that they're invested in a particular technology space. But other than the marketing and business development aspect, there isn't necessarily deeper engagement or any software development activities. A third way to think about your investment strategy is this concept of being collaboration-led. When you are looking to engage in community in order to directly build joint solutions, either with your customers or partners, and you're typically doing this in a context of writing software for upstream open source projects. The goal may be to enhance the state of the art in an upstream project in a way that adds value directly for your customer, and to be able to do so by collaborating and co-creating with your customer in that upstream context, so that your subject matter experts and their subject matter experts are able to work on a shared infrastructure in a shared problem space and be able to iterate on technology features together in a very tight feedback loop. Our fourth way to think about how to do your investment strategy is what I call network-led, which is just a fancy way of saying your own employees are excited about a particular software project or a technology space because their friends are interested in it, and they're seeing the potential rise in popularity of a particular technology domain area. And in these cases where you have a particularly passionate employee who wants to engage in that project space, or at the very least closely monitor developments there, your business case, your goal is to uncover your business case there for future investment by allocating a small amount of resources to investigate along the lines of that particular employee or group of employees' personal passions. So sometimes you're going to architect your strategy around the engagement of your employees with their own networks and see what business opportunities are going to be uncovered in the future. And then the last way to think about how you're going to architect your investment strategy in community is this concept of being thought leadership led. And in these cases, you're not necessarily engaging with a particular community in order to build a product. You're not engaging with a particular community in order to do traditional business development activities. You're really engaging in that community in order to help your customers solve their strategic business problems. So I think a great example that I'd like to share with folks is if you look at the FinTech Open Source Foundation, these folks are focused on FinTech and financial services. In addition to being a foundation that hosts various open source software project development, they also have a couple of different working groups that focus more on the organizational challenges and opportunities of engaging with open source software. So one of those is their open source readiness working group, where individuals from various FSI firms come together to perform knowledge sharing, to ask questions of their peers in a secure environment, everything from questions about open source licensing strategy to understanding what sort of developer training resources might be required for developers at FSI firms to be able to effectively use open source software as part of their day jobs. The FinTech Open Source Foundation also offers an inner source significant interest group. This is a relatively new group within the FinTech Open Source Foundation, but the membership has taken off like wildfire. And the idea behind this significant interest group is to help financial services firms be able to adopt inner source methodologies and to understand how the principles of open source development, as instituted behind the firewall through inner source, can help the organization achieve organizational culture paradigm shifts so that folks understand how to collaborate across teams, across silos, and to build trust and mutual rapport within the organization. And if you're an old school open source person like me, you're hoping that as they start their inner source journey, that they eventually graduate and begin fully participating in open source communities. So the truth is that your most successful community engagement strategy actually combines all 5 of these elements. And it may be that your participation in a particular software project, foundation, or industry consortium may encompass all 5 of these elements or only one, but you need to be able to make sure that you have elements of each aspect as part of your engagement strategy in order to be successful. And the other key aspect of this is making sure that as you're doing this cross-functional engagement with your multi-pronged strategy with all of your external stakeholders in various community spaces, you're also doing that behind your own firewall within your company with your internal stakeholders. There is never going to be a successful community strategy related to verticals that does not involve your engineering teams and your sales teams and your marketing teams and your business development professionals and all the fine folks who are doing your data and analytics to make sure that there's return on investment for the fine work you're doing. So again, holistic approach to community engagement, and that holistic approach should be applied within the community context and equally so behind your corporate firewall. So let's talk about different ways in which you can architect your community engagement strategy from the perspective of different ways that engagement strategy can be seen in the various activities that you'll do, kind of like hands-on, boots on the ground. So when you are thinking about how you are going to architect that strategy, you need to have a very clear understanding of what you think final success looks like. Engaging with a particular community because you think that it will open up the doors for your sales teams to have new conversations with new sets of customers is a good and noble goal. That is not an effective view of what success looks like, nor is that something around which you can put measurable success criteria and understand if your community engagement strategy is actually producing return on investment for your company. So success can look like many things depending on your strategic goals. It could be that you've brought a new product to market. It could be that your customers have deepened their relationship with your organization to the point that they are calling you for advice about how to select the next products for their software stack to make sure that whatever they choose is good for them for the next 10 years. It could be that you're a trusted partner in helping your customers achieve digital transformation because you're able to bring knowledge and wisdom to them about open organizational principles. Or it could be that success looks like having enough information about a particular technology area so that when the market evolves and it's very clear that, for example, we're moving from Docker to Kubernetes, you are ready to engage fully and change your strategy in a very agile fashion to meet the needs of the market while still serving the needs of the customers that you have engaged with who have not yet begun to think about that evolutionary transition, so that you can bring them along with you as that change is made. Again, talking about really, boots on the ground topics and how to roll up your sleeves and get things done. Sometimes you're going to need to look at forging your own new community. Those folks who have deep experience in the open source software world are probably groaning when they hear me say this, because we are all thinking, not yet another software foundation. But enough of that inside baseball. The goal here is not to create a new membership organization for every single piece of technology that is brought to the fore, or for every single new industry space. But it is important to consider that for industry verticals that are just now starting to understand their own journey with open source. So I'm thinking about folks like manufacturing, retail, energy to some extent. It's not the usual strategy of saying, oh, wonderful, we'll show up in this particular software foundation, in this particular open source software project, and we'll join this particular industry consortia. Those resources may simply not exist at this point in time. So instead of a more traditional meeting them where they are within our previously mentioned 3 pillars, you may take your first steps in the form of customer education. And what I mean by customer education is this can be anything from something that looks like a traditional lunch and learn session, where you join your customers at this point virtually, but once upon a time it was in person, literally over lunch, to talk about a topic that is more focused on educating the customer about a particular technology area. So at Red Hat, we have something called the Open Source Enablement Community of Practice, of which I am a member. And the goal of that community of practice within Red Hat is to create materials that can educate customers, prospects, or honestly, anyone who is interested in learning more about open source software and open source development methodologies, so that they are prepared with some tools to begin considering their own perspective on how they consume open source, how they contribute changes that they make in those projects back upstream, and to understand how the principles of open organizations, which were really derived from the principles of open source software development methodologies, how those principles can help to inform a company's own approach to organizational change, because it's great if we're choosing the best possible tools, but if we're not empowering our employees to be able to work in a new way, it doesn't matter how great our tools are, they're not going to be able to succeed in their quest to transform the business. So the key takeaway here is, if you are operating in an industry vertical space where it is fledgling in its understanding of participation in open source, go the traditional customer education route, really focus on making sure that your constituents have the resources and tools that they need to more deeply investigate on their own so that they can begin more fully participating. Meet them where they are and take them along on their journey with you. It's also most frequently that as we're looking at how we're putting together our community engagement strategy, that we're looking at, what is our path to product? And this is particularly important for organizations that don't necessarily have a huge level of resources to bring to bear. At Red Hat, we have 16,000 employees worldwide. We are, I like to think of us as lean and mean, and applying our resources where they will have the most value. When I look at some of my friends who are working in the small and medium enterprise space, they are absolutely in the same boat. You do not have infinite resources to bring to bear. So when you're looking at places to invest from a community perspective, look where you actually have a possible path to product, and you have engineering resources that you can dedicate to the problem space in a sustained fashion, and where you can bring the most value by contributing technical work product. While you're putting together your community engagement strategy, remember, even though market verticals encompass the entire world, right? So if you look at retail, things are sold all over the world. If you look at energy, people are consuming energy all over the world. You cannot architect a one-size-fits-all strategy and hope that it will be successful. And this encompasses a few different aspects. One, it's probably obvious, but I will say it anyway. Local customs and the way that different people do business based on their culture, based on their native language, based on the customs that they have known since childhood matter. So, do not find yourself turning up to an event in Europe with a key theme of that event being a focus on digital sovereignty and talk about the amazing traction that US hyperscalers have gained in creating AI infrastructures. True story, wasn't me, don't be that person. You also have to consider local market dynamics in terms of the actual regulatory bodies and the different laws of that region. So right now I'm thinking of, for example, if we look at New Zealand. So New Zealand is not what we would call a world major market, but they are also the first country on this planet to pass regulatory legislation requiring that financial services firms consider climate risk as part of the risk assessment in their investment portfolios. And if we look at how well New Zealand handled their response to COVID, I would say that they are an excellent set of folks working in the public policy space to help us understand how we react to external pressures and, in fact, to crises in a legislative and regulatory way. So I think that it's pretty clear that the rest of the world is going to go in New Zealand's direction pretty soon. And it's also worth noting that there's an open source project called OS Climate that's spinning up precisely to address these particular dynamics. Not to pick on the FSI space or necessarily on New Zealand, although I'm a big fan of that particular place. If we also look at things like, for example, the automotive vertical, you may be looking to, as Red Hat is doing, create an operating system that runs in vehicle. And that's wonderful. Red Hat is a platform company. We are hoping to provide the best possible solution to the global market. But turns out, if you're looking to do that kind of work, you had better know TÜV in Germany, the local certifying body who makes sure that consumer products are safe. And this is everything from my daughter's toys to how automobiles operate. So again, global perspectives on verticals, but if you do not keep in mind the needs of local market dynamics, both from a culture perspective, a regulatory perspective, and also a human values and personal beliefs perspective, your strategy is not going to be effective. It is very important to realize that you cannot do it all. And this is equally true of very large firms and very small firms. For very small firms or small medium enterprises, it's very obvious that you have limited resources to allocate and you cannot do it all. For very large firms, the concern is even if you have many more resources to bring to bear in a particular vertical market space, that your approach is fragmented because you have too many folks working in too many disparate areas and you're not able to effectively bring it all together holistically with your internal and your external stakeholders. So while you're trying to decide what to do, since you cannot do it all, my advice to folks is to focus on creating the maximum value in your particular community engagements. And I don't just mean what is going to create the greatest return on investment for your particular company. It's also how you can provide the most value within those community spaces and have the most positive impact for all participants, because through that creation of maximum value for everyone involved, you're not only helping your customers and potential customers more effectively achieve their business goals, you are also ensuring that you have deepened your relationship with these folks, and then they will be more excited to hear from your sales force when they call upon them later. Last but not least, it's important when you're architecting your any community engagement strategy, but particularly for vertical markets, because your work in these vertical markets communities directly, very publicly touches upon spaces in which your customers and partners and prospects operate. That when you are thinking about how you're going to engage with a particular community, you need to make sure that you have a plan for evaluating ongoing investment and what your exit strategy is when you are ready to leave a particular community. And there's lots of reasons for leaving a community. It's not just that you found that your investment in that community didn't provide you with the results you wanted. It may be that you've engaged in an open source software project in order to advance the technology state of the art, and that software project has achieved its goals and is now in ongoing maintenance mode, and there are sufficient maintainers available to ensure that that code base stays healthy and strong for everyone who needs it. In that case, you may look to reallocate resources. It may be that one of your employees who is a subject matter expert in a particular area moves to Tahiti and is no longer available to bring to bear their technical prowess in this project space. It may be that budgets have shifted. There are all sorts of reasons why you may look to a particular community. It's perfectly fine to make an exit gracefully, but it is always important to make that exit gracefully. And you can do so by giving adequate notice to the organization from which you are departing. Some organizations actually have it written into their bylaws what the notice period is for your departure. So make sure you always honor those bylaws when giving notice that you will no longer be a member in a particular membership-based organization. And whenever possible, if you can, try to line up resources to replace you when you're ready to leave. This may look like if you have the skill set within your organization and there's interest to do so, potentially helping to line up other funders, other software maintainers, other marketing and documentation folks even. When you are ready to go, leave the project better than you found it, and make sure that your departure is one that does not leave people struggling because they had relied upon your efforts and those efforts are suddenly absent. So we're about to get to the end of our remarks today. I think I want to leave you with a really, well, from my perspective, a really important set of guidelines, and that's the song remains the same, right? I've talked an awful lot about engagement in communities from a verticals perspective today, and a lot of specifics about how those particular vertical engagement strategies touch on different aspects of the business. But no matter what, success in community engagement isn't necessarily different because it's about verticals or it's about a particular market. It's really about how you meet the needs of your audience, how you provide them value, and how you help them be successful in their own quest. So one caveat, I said that your approach, be it for verticals or traditional open source software project open source community management is the same, and I'm about to go back and reverse my previous perspective there in just one way. And that's, if you're doing verticals community engagement, you really need to hire someone who is a domain expert in that particular vertical. Once upon a time, if someone had asked me, what is the key to hiring an effective resource for community engagement, I would have told you that the most important thing is, if you're working in an open source software context, that person that you hire has a great background working with open source communities and open source projects, that they understand open source software licensing, that they understand the dynamics of developer engagement from a community perspective. And in an ideal universe, perhaps they have been a software developer who is community minded within the particular project that you're looking to engage with. That's great. That's actually really, in my humble opinion, really good advice for sort of our traditional community engagement paradigm, where you have one project at the center with different spokes of engagement across that wheel. For verticals, I have to tell you, if you do not hire someone who understands that vertical and speaks the language of that vertical, it does not matter how expert your person is in understanding open source communities and understanding community engagement and understanding things like principles of design thinking, they will not be able to meet their audience where they are. It's just not possible. So when we've looked at building out our vertical community architecture team, we have focused on finding the right individuals with a background in the particular vertical. And in some cases in 2 cases, we have been fortunate to find unicorns who not only have expertise within a particular vertical domain, but also experience working in open source communities. So I am very privileged to be able to lead a team, including Miss Lisa Kaywood, who has 20 years of telco experience and has spent much of that time working in open source project contexts, including time at the Linux Foundation. And also, as we have hired for support of Red Hat's automotive community initiatives, I've been lucky enough to bring on board Jeff Ozier-Mixon, who has a background in embedded systems, has worked on different initiatives within the automotive space, and has also been a long-time participant in open source software projects, including a long time as the community manager for the Octo project. And as I mentioned at the very start of this presentation, my single shameless plug, I am hiring right now for a community engagement professional focused on the FSI space. So if you are a unicorn who understands and can speak fintech and financial services and also knows open source software communities, I would love to hear from you. If you are a person who understands fintech and financial services and would be excited to learn more about the process of community engagement, I would love to hear from you as well. You'll find my contact details at the end of this presentation. And finally, folks, the absolutely not secret formula for successful community strategy. For verticals, hire the right person with domain expertise. For every other type of community engagement, again, the rules are the same. Understand your audience. You need to know what the people you are engaging with need, what they need for their customers, what they need from you, and how you are going to help them get where they need to go so that they understand the value you provide to them in a community context and a business context. You need to meet your audience where they are. So if they are very early on their open source strategic journey, you need to probably do a lot more work in the customer education space. If they are advanced in their journey with consuming and contributing to open source software, you're going to be meeting them in grassroots developer meetups, and you're going to be collaborating and co-creating with them in upstream open source projects. And perhaps most importantly, always, you need to provide genuine value. It is not enough to show up with an opinionated technical stance that you think is important because it helps you sell your products. It is important to show up in upstream project contexts with technology that adds value to advance the state of the art. It is insufficient to show up in a community context simply to market your company and to market the products that you sell. It is important to also show up in that context to help the organization's members be successful in their goals and also to help the strength and the reach of that organization in which you are participating so that you are serving all of the constituents within that project, not just yourself. And for those who wonder why you would be focused on providing more value than you capture, it has been I'm old, nearly 20 years of experience working in the open source project space and in the business context that if you do this work in community where you are focused on providing genuine value and creating more value than you capture, your customers will like you and they will want to do business with you, and they like you and may want to do business with you because of that deepened relationship, even more than they appreciate the cool software you produce or the products that they can buy from you. And my dear friends, that is the conclusion of my presentation. I will now admit that I cannot see my timer. So hopefully I have not finished very, very early, but I will find out now. Hi, how'd we do?
Okay, so thank you very much. There is some questions here, so are you ready?
I will happily take questions. Please tell me what they are. Wait a minute while I stop. I would like to stop sharing, and I would like to be me. I'm me. Hi.
Okay, so I'm going to read it up here. With your background as community manager, and now perhaps being more into business, how would you say communities have changed over the years?
Oh, wow. That's a really great question. Okay. I'm going to do story time. So once upon a time, a very long time ago, I started my working career with open source software focused on a community that some folks may have heard of called Google Summer of Code. And the idea there was to get students involved working in free and open source software projects during their summer holidays. And again, I'm only talking about my own experience. Maybe I'm just super naive, but I think once upon a time, there was a lot of focus on the idea of engaging with open source projects and open source communities because you were particularly passionate about either the technology, the humans you were collaborating with, or both. And I think over time, as open source software has become ubiquitous and more businesses are recognizing the value of consuming open source software and potentially contributing to open source software projects, there's become more of a, I don't know what the right word is, corporate focus on open source software. So once upon a time when I talked to free software hackers, they were like, I believe in freedom. I believe in the importance of having an auditable code base. I believe in the importance of my software being available for anyone to use freely for whatever purpose they require it to be used for. And I believe in the equality of everyone having access to my source code so that a big company can use it, but also a nonprofit that's trying to serve underrepresented groups who need help can also use my software. Now, when you talk to folks about like, why are you excited about working in open source software projects? I hear more often like, it's going to help me get a job. If I work in open source, I get to work with really cool stuff like Kubernetes, and lots of people are hiring for Kubernetes talent. Or, I want to work on open source because that's the future of software development. So of course I want to be engaged with, the how things are going to be done the best way possible in the future. I don't know how to feel about that development, to be honest, because I am a romantic idealist who is constantly disappointed with the state of the world. So on the one hand, I think like, where is the love? Why are we not all in it for the love? And then I think I'm in my 40s now. Maybe my idealism was more because I was a younger child when I started out with this process. I will say though that I'm really fortunate to be able to work with people who are working in so many different areas of open source software development. It's not just providing people with Linux solutions or containerized stuff, right? Like just last week, I was talking to the Digital Impact Alliance, which is part of the United Nations Foundation, and they're creating software solutions in order to help people in emerging economies to be able to create economic development models for themselves and their fellow citizens using open source software. So there's still a ton of idealism out there in the free software world, and I have my best moments when I engage there. But I would say communities over time have become more business focused, less passion focused, and that may just be the natural evolution of any community as their output becomes more popular. But if you would like to hang out with me in the romantic idealism quadrant, that's cool too. We have good coffee. Please join us. Thanks.
I wish I was in my 40s, by the way. And how would you say the companies?
I'm sorry, there's so many words.
How would you say the companies have changed over the years?
Oh boy. Well, there are so many different ways to answer that. One, companies have gotten a clue that investing in their open source strategy is a good idea and benefits their business in ways that probably I didn't think were possible when I first started working in the open source space. If someone had told me 10 years ago that, Microsoft would embrace Linux, or if someone had told me, 10 years ago that Amazon would have an open source program office that had hired some of my best friends, I would have laughed. And invited you to the romantic idealism corner to have coffee with me. So the companies have changed by really figuring out that open source software is an important part of their strategy. And this is companies in every single market vertical. It just depends kind of on where they are and figuring out that is true. I will say, and this is probably my own biased naivete, I would say that companies have, this comes from working at Red Hat for 6 years. If this is not your experience, I'm sorry, folks, your mileage may vary. I would say that companies have gotten much more sophisticated in understanding that sort of a non-hierarchical, bottoms-up approach to technology development and organizational structure provides better results. Because if you don't empower your employees to be successful and you do not create a genuine environment of psychological safety for them to do their work in, you're not going to get the best possible results. And companies that do allow their employees that psychological safety to both fail and experiment with all of their colleagues, right? Not just the colleagues in their little cubicle farm area or in their one department or in their like big team, all of their colleagues. Turns out your best possible talent wants that opportunity. And if you do not provide it to them, they will take their talent and they will go elsewhere. And so I am thrilled to see more and more companies, opening up to the idea of sort of open organizational principles and moving away from traditional hierarchies to environments that support wider collaboration and provide, again, genuine psychological safety to their employees, so that when you tell people iterate, experiment, make big changes, some experiments fail, that it's actually true, right? Because you get the best possible results that way. Don't get me started on licensing changes by VC.
No. Even I won't do that.
I do understand it. I'm back over here in the romantic idealism corner with my coffee, drinking my coffee, sadly. The end.
How do you ensure the longevity of the community? Contributing is hard, but making it last over time is hard. Perhaps it should be harder or expensive.
Okay, that is also an excellent question. I'm going to give you many answers. Okay, so if you talk to my friends over Open Collective, or if you read, I can't believe I have forgotten her last name, and I can't believe I have forgotten the name of her paper from the Ford Foundation. There's a researcher named Nadia, and I am humiliated that I do not remember her last name. Excuse me, Nadia. She was briefly at GitHub. She wrote a paper for the Ford Foundation called Roads and Bridges, where she was looking at the impact of a lack of funding on our vital infrastructure, because so much of our vital technology infrastructure is open source. And in the case of some software, there are 1 or 2 people working on it. They have a consulting firm that pays their bills. You hope that they have time to make sure that SSL works properly. Turns out that is not a winning strategy. So to some extent, long-term sustainability of a project is about making sure there's funding to pay the people who are working on it so that they can focus on improving that software. You can do this through direct funding of projects through like a software foundation, or direct funding to that project itself through other vehicles. You can do this by sponsoring open source projects through platforms like Open Collective. And you can do funding of projects through other means, like GitHub has like a tipping function. I don't think we care about Git tip anymore. That was a long time ago. Like I said, I'm old. So again, projects need money. Now, if you talk to my buddies in inner source land, they will tell you that it's not so much that open source project communities need money, it's that they need maintainers. And you can easily conflate the concept of maintainers with money. And they will tell you that the best way to ensure the sustainability of free and open source software projects is actually to help developers within traditional firms who do not understand how to engage with open source software projects, to train those developers to be able to do that work and contribute the work they are doing within their companies into open source. Because there are way more developers who understand how to do software development well in traditional organizations that don't participate in open source projects than you can ever hope to train up or recruit developers who are only know the open source context, right? And then lastly, open source projects need humans. And they do not just need humans who write code. They also need humans who have other skills. And if you are a company who cares about a particular free and open source software project, it's wonderful if you can provide them with cash. It is wonderful if you can provide them with software development resources. It is also wonderful if you can help provide them with resources that do that vital glue work that mean any project is successful. Project managers, documentarians, marketers, people who put on events, like all of those things are required in order for a community to be sustainable. And it is not just from the perspective of there's a whole list of work that needs to get done. You also have to consider that if your primary interest in that group is the code they write, if you do not give humans to support these other functions, your developers in that project are going to be doing these other functions. Turns out maybe you want them writing code. Maybe you would rather have them writing code than worrying about things like, do we write the press release about our latest release of fabulous software? Turns out you want them writing the software, not the fabulous press release. I hope that was a useful answer to this question. If not, you can get me on the Twitter, on the LinkedIn, or by email.
Super.
I remember to unmute. So there's one more. No, actually, there's a couple. Yeah.
Fill in that Nadia's last name is Eggvall.
Eggvall, right?
Yeah. That's the one.
Too late now.
In the comments.
So do you at Red Hat use some method to calculate the costs in your community engagement in relation to the pros and cons?
So the answer to that question is yes. And I have to say that to some extent, it's more an art than a science. And one of the reasons it's more of an art than a science is we make our decisions about community investments from a wide variety of perspectives, right? So if you remember kind of like those first 5 options, I said like, technology-led, advancing the state of the art, or sales-led, where there's a business development aspect to it, et cetera. So those are part of the criteria that we use. You notice that there's no like specific KPI attached to any of those approaches, right? So we measure the return on investment in a couple of different ways, right? So for some types of investment, there are very traditional ROI metrics. So for example, we go to an event that was put on by the FinTech Open Source Foundation. We like engaging with these folks because they do cool work in the FinTech and financial services space. How many speakers do we get on the program? Were they talking about Red Hat technologies? Did we get to do Hello Small Human? Did we get to do any lead generation activities as part of this participation? Did somebody get into our drip campaign? Did they attend an FSI coffee break as a result of getting into our drip campaign? Etc. Right? And then, do they finally make it through the funnel to buy more Red Hat? We hope they make it through the funnel and buy more Red Hat. I like my job and I appreciate getting my salary. For some community engagement activities, we don't have those sorts of rigorous metrics because it is more about deepening the customer relationship and deepening the perceived value of our company from a strategic thought leadership and helping you along on your journey perspective. And I have been doing community engagement now for almost 20 years. And I will tell you right now, good luck measuring that. I mean, the person who tells me how this could be done, I will invest in your company. I will subscribe to your newsletter. I will hire you to work for me. Like the closest thing I have ever seen is this concept of the DevRel qualified lead, which folks should check out. A very talented community strategist named Mary Thengvall did an excellent write-up on DevRel qualified leads and how you can look at sort of community engagement metrics and map them to traditional business metrics. But frankly, it's impossible. As far as I can tell, and I love solving impossible problems, I really do. But as far as I can tell, it is impossible to be able to measure that people feel good about interacting with you and they trust you and they want to get your advice and they want to contribute to your livelihood. You feel that, right? You don't get a Tableau chart about that. You just don't. One day we might get there, but we're not there yet. So for some types of engagements that are really focusing on like deepening the customer relationship and establishing intimacy with the customer or partner or prospect, the success metrics are, do we know that we did well and that they want to keep talking to us and they respect what we have to say, and do they trust us? There's another human in the gypsy room.
Probably the next speaker.
This is probably the next speaker joining. So
I will clearly risk you on having a heart attack now, but I'll fire off one more. Do you have any interesting clash with a community, like where you had a disagreement?
Me personally or my company?
Company and personally.
I will say from a personal perspective, there have been communities with whom I have engaged where I have preferred to spend my work hours focused on other communities while making sure that I met the needs of my stakeholders in that community.
Okay, pretty good answer.
There will be no naming of names. I do not tell anybody about the private conversations I have with anyone ever. That's why people trust me, and I am not going to poop on people, even if they deserve to be pooped on. But if you want to find out about people with whom I choose to spend less time while still wishing them success in their quest, we can do that one day over an iced tea or a beer. But I will still not name names, but you may figure out who it is, and that is between you and your own imagination. From the company perspective, I mean, I'm sure it's happened. It has not happened. It has not happened so much in the work that I'm doing right now. I think you can probably guess that some people were not super thrilled with Red Hat's engagement with continuing to sponsor production of CentOS Linux. I didn't work on that. I just want to give mad props to my colleague Rich Bowen for his engagement with that community and his stewardship of the community through that process. It was not easy for anyone involved. I would also suggest that you have an iced tea or a beer one day with Brian Exelbeard and Rich Bowen to hear some more about some of the behind the scenes stuff that went there, which I am not at liberty to disclose, but I will say the situation is a lot more complex than ends up on the front page of the Register. And I am admittedly, I'm not gonna lie, I am a Red Hat fangirl. This company has treated me very well and with a lot of respect and has taken care of me when I needed to take medical leave, to take care of my daughter, et cetera, et cetera. I've given talks about that. Like, my biases are clear. But I will also say that that situation is a lot more complex than meets the eye. And I feel like things could have been handled differently. Maybe people made choices I would not have made, but I also think that folks who think that Red Hat has acted in some kind of evil or horrifically bad fashion in this situation may have other information that they wish they had before making that decision.
Cool. We need to stop now, otherwise Johan will kill me.
I don't want to kill you, I like you.
it's been very, very nice.
No, I can be. I'll be the good cop. I like that. Finally.
Thank you very much, Leslie. Lovely to have you here.
Thank
And
you,
we will
Thank you for having me. Cheers.
We will be back in a couple of minutes with Jan. Cheers.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
And welcome back. I did not suffer a heart attack. I'd like to welcome Jan Ainali to the stage. So Jan, please take it away.
Hello, and thanks for having me. So my name is Jan Ainali. I work as a code-based steward at the Foundation for Public Code. And today I'm going to talk a little bit about how we're helping public organizations collectively develop and maintain public code. And I'm going to start a little bit with the why, because that will give some insights to some of the hows and the whats, like what we're trying to do. So let's zoom out a little bit and get a little bit philosophical. Because when we're thinking about code, it's really all about processes. And another very long-running process is the city. It's perhaps the longest-running continuous process that humans have created. It has evolved over time, and technology we use have seen progress as well and been used in cities all the time. And the last several decades have seen a rapid acceleration of technological innovation involving software services at the scale of society. Or rather, perhaps the exponential pace of the technological development is now in this hockey stick part of the curve, so that we're really seeing the effects and that the development is not just increasing linearly. And weathering these disruptions from software and how it's causing transformation, we can now ask, is software becoming infrastructure? This is sort of a way that we have always operated. Humans invent things all the time, and the first 30 years or so, we call them technology. And then, if they work, we call them infrastructure. And the shift from technology to infrastructure is huge, because if that's the case, there's a totally different set of actors involved in the provisioning of these. And cities have always been assigned to turn technology into infrastructure for the benefit of society. And they have been doing this, transforming technology into infrastructure through iterative generation of policy, or civic code perhaps. And this civic code, or policy, it's a set of rules determined through public governance model that defines the possibility space of society. And we have seen changes on these possibility spaces over time, many times, through policy. For example, the change in civic rights, how property rights works, how we want the industry to behave, and how we like to do trade. And of course, how we manage our transports. But software? Can we now open up a new possibility space if software becomes infrastructure? And considering the policy we have today and the way it interacts with software, can we truly say that we have a digital society? Because the way policy affects software is mostly uninformed and vague. And the other way, the way software affects policy, it's very hard to say, because that's most often proprietary and closed. So we believe that software that runs our society can no longer be hidden in proprietary code bases. They cannot be producing data that's not owned by the public or licensed at ever-increasing cost from outside companies. Instead, governments need technological sovereignty so that they can shape the functioning of the public software, just like they can shape policy legally formulated in laws. A software provider might think that not all requested changes in software are in scope with their vision of it. Well, it turns out, in a democracy, policy cannot be out of scope. So if these two are becoming conflated and interweaved, there's something need to be done there. Say, for example, If there's a local party running on the ticket to make parking fees higher on weekends to discourage people to make trips to the city, a car-free Sunday or something like that. They get really popular in the city and they win the election with a big majority, and the first thing they want to do is crunch this through the policy process. And they succeed with that because they have the majority. Then they go to the software provider of the parking machines and they just answer, nope, no can do, it is out of scope for our business. I think we all can agree that it would be an unwanted situation. Instead, public software must reflect the values of the society it serves. And organizationally, each city is remarkably different in how it evolved in software adaptation, development, and deployment practice or cultures, in the same way as the cities themselves are very different. However, cities have uncovered some recurring design patterns in emergent needs among civil servants and citizens for types of digital goods and processes, just as there are similarities in everyday life. And forward-thinking cities are already building public digital infrastructure for themselves. We see this in transport and transit, in schools and education, in the healthcare, and in libraries. All these cases are examples when the software implements policy produced by and for the public, and that's what we're calling public code. Sometimes these are even open and open source, but perhaps not really reusable yet. You've heard about Italian food and French cinema. Can we have just software? No. Software too has terroir, one of the most culturally situated things humans can produce. One obvious example is that they are made in their local language. Something else might be that they implement local policies. Take, for example, how Amsterdam takes waterways and canals into account in a way that Las Vegas would never even think of or imagine. So if we can overcome these problems and start sharing code bases, cities can spread out the risk of development on several partners, accelerate production through collaboration, and push against the dizzying cost of licensing private alternatives. Cities need to develop open, adaptive, and reusable public code bases together as part of their core civic functions. So I've been using the term code and code base a little bit. I'm going to try to go a little bit what we mean with the difference of these. So we know modern software. It's usually not a single monolithic application. Instead, it's made out of components, and these components can in turn be made of other components. And the beauty of them being digital is that they can easily be copied and shared. And we can think about this as they're using the same blueprint and being shared over and over again in different places. And we can adapt it, modify it, and configure it. And preferably by making those adaptations available back to the original code base. In that case, we can have a truly collaborative ecosystem. And that is sort of what we're trying to do here at the Foundation for Public Code. We want to provide cities with the tools and processes to do so through a set of services we call code-based stewardship. We're a nonprofit, we're a member-based association, and only public organizations can become members. And what we're trying to solve here is trying to figure out, well, in a space where what the public sector feels comfortable to do when they're developing software, and what vendors are interested in doing, and comparing that to what a code-based community might need, there are not perfect overlaps. For the public sectors, there might be things that are hard to procure or hard to know who is responsible for if there are several public sector bodies involved. Vendors might not see why they should invest in certain parts, and the community might not even want vendors to own those things. And that's where we come in. We're trying to fill these gaps that are hard for the traditional stakeholders to solve. And I mentioned we do this through code-based stewardship. And these have sort of 4 pillars. But I guess it's also important to think about the stewardship part. Stewardship is not something we use in our everyday terms, perhaps, but you can think about it almost like we're taking the role of a coach. We want to bring the most out of the community and give the code base the best possible conditions to succeed. We're not actually developing software ourselves, but we're helping the community to figure out what is important for them right now. And one of these pillars is the community. We help the communities around code bases organize, grow, and thrive by processing feedback and contributions, organizing events and community calls, and we also provide basic infrastructure like mailing list, a Jitsi server, a chat, or something like this. And we also try to help building effective models of governance. And one tool we made for that is the governance game. This is a card game that helps you play out the role and sort of almost like role play what can happen in a code base and different kind of scenarios to make sure that it's set up in a way that is resilient and sustainable. Another pillar is product. We help shape the code base into mature products. So by growing awareness and increase the adoption of it, we do that by help create branding and think about communications. We provide guidance and support for development and design. Another pillar that is important is support. We make using open source less risky by helping with technical questions, but also thinking about packaging and distribution. Start talking about and not forgetting to develop training materials and trying to help vendors, both companies and NGOs, sell, implement, and support the product so that it becomes a true ecosystem and not a single player in the field. Because if that's the case, we haven't really gained a lot. And the fourth pillar, and perhaps the biggest pillar, is the quality. We will enable agile development in an ecosystem of trust for public institutions and their collaborators by checking the commits and the merge requests on code, policy, and documentation for compliance with the standard for public code. The standard for public code, you ask, what is that? Well, it's a set of certification criteria that we've developed, and we use it to audit the contributions that's coming in. We build this together with everyone openly. It's collaboratively defined, and we have versions. You can see here the versions. This is an old photo from 0.1 to 0.1.4. We're on right now at 2.1, but it's still in draft, so we can help develop this. And I'm not going to go very deep in this, but I'm going to give you a little bit of an overview here. It consists of 15 criteria, and they're all sort of a collection of good practices. If you're developing code right now, you're probably already doing most of it. And if you're not doing all of it, I guess you wish you're doing the other parts. And in the best case, you just cut some corners to make sure you make a delivery on time, and you're going back and paying your technical debt a little bit later. It also has some unique parts in how policy plays in. So that's where the public code comes in, which might be new for if you're are a traditional code developer. And all these four pillars together is what we call the code-based stewardship. That's what we're trying to help and do. And just to summarize it again, it's community development, product management and marketing, making sure the quality is high, and also making sure this support is successful. And so far, we have been talking with 2 European directors, 4 national governments, 4 national frameworks for municipal collaboration, 2 provinces, and 22 municipalities in 9 countries. But even so, we're just laying the foundation. We are the foundation, but we're also laying the foundation. We're quite young. We are only existed soon for 2 years. But we're trying to move code bases through this life cycle of a product towards full stewardship. And we have looked at more than 10 code bases developed by municipalities. And for now, we're moving forward with 4 active development projects. We try to make quite a large commitment when we're choosing to work with the code base. We want the code base to be able to rely on our support for a long time, just like you would like to rely on any public infrastructure. You're not expecting the street or the street lights to be gone the very next day. If it's set up there, it's meant to last. This means also that we try to find code bases who want to make a substantial investment for the future, to know that they are long-term, to know that they want to collaborate and grow and to be reused all over the world. And to do so, we want them to buy into the standard for public code. That being said, we are a young organization, and we try to develop our processes so that we can scale globally. For active development process, as I mentioned, that's a drip in the sea, so we need to scale a lot. If you have any ideas of how we can scale more, you're more than welcome to connect with us. So at the Foundation for Public Code, we try to provide tools and processes that bring people in institutions together to collaboratively build and maintain software as public infrastructure. Also, just like Red Hat, we're also hiring, so check out our open roles. And I hope I didn't go over time, that there's still some time for questions here.
You're all good.
All right. And I'll leave the credits up here for a little bit, also so that you can see my notes, but I'll see.
Yeah, and we will share the slides post-event.
All right.
So that is one thing. I'd also like to mention that if you're interested in public money, public code, and how to collaborate, there is a community event tomorrow organized by NOSAD that you can find on the community events page. So I encourage you to join in there as well. Henrik,
I will
collect some questions.
Okay. It sounded, I'm reading up here. It sounded focused on organizations. You also mentioned companies. Do you work with companies? And if so, how?
Yes. So I guess the biggest part that it is for public organizations. So the main developer might be a public organization or a company. We don't really care about that. We care a lot that there are several able parties. Because if it's just like, say, the city of Amsterdam who can develop it, then how could the city of Helsinki do anything? So, or the city of Helsinki might be able to do it because they are a large one. But say, Östhammars kommun in Sweden, which is tiny, like they would need a vendor to be able to help them with the services. So yes, we want a complete ecosystem. So we need companies involved.
Cool. Sorry, I need to rephrase of one question. So I'm doing 2 things at a time, which is totally impossible for me. What code is infrastructure and is game infrastructure?
I guess that depends. So we're thinking about code used in public organizations and in the public sector. They might be using games, I guess, perhaps in school situations. But I'm not games only for pleasure. I don't think that really would count.
Okay, I guess this unbiased question is, I'm having a hard time collecting the pieces here.
But is the original? I'm trying to reformulate what he's writing. So if you want to jump into the YouTube comments afterwards, there's the unbiased alias.
So the original question is, what is the source code for? Question mark. Proprietary vendors are doing this very thing, and they are a lot better at it than writing software.
I think it comes into democracy. Is there a point in everyone having the source code when not everyone can read it? Or
Excellent.
All right.
Here's an update here. What are the 4 selected projects and why? I guess, okay.
Yes. So I'll start, I guess, with the first one, which is sort of why we need open source. And I guess that's partly for transparency reasons, and this varies across where you live in the world if that's very important to you. But it's also about the ease of sharing and being sure if you're a public sector body in another part of the world and you want to know that can we legally start using this, and if it's being developed with some sort of homebrew proprietary license in Kalmar, perhaps the city of Buenos Aires really don't know what to do with that. But if it's using a standardized AGPL license, anyone can sort of figure out how that works, and it's easy for them to pick out. So it's a very good tool, open source, to be able to reuse and share code. And then to go to the second part about which code bases we're having right now. For now, they're all being created by different Dutch organizations. That's why we're starting here in the Netherlands. But as I said, we try to go global. So one is a sort of a reporting system for cities where citizens can say, oh, here's a streetlight that is out. And it's not only reporting them, but also a big backend, so it can be routed through a large city with a lot of departments and also contractors who might be actually taking care of this. Also a really case management system that is sort of a middleware layer trying to make sure everything connects. A way to connect policy to geography. It's based on a Dutch law for environment, and with environment in this case, they're actually thinking about everything that happens. So not only the nature environment, but also building permits and stuff like that. And the last thing is sort of making a mock-up site for a municipality so that you can try out and showcase components that could be used in a public setting. So and the names of them are Signalen, OpenSAC, Omgevingsbeleid, and Demodam. So I think we need to work on some of the Dutch names here so that they may be easier to understand, but yes.
I mean, having Holland and Finland as your examples, that doesn't make for good names in other country. But we're ever so slowly running out of time. But if you want to discuss this, I see there's a heated discussion in the comments.
Right.
But the NOSAD workshop is there, and there will be a lot of stakeholders there tomorrow. So make sure not to miss that. And I'd like to extend a big thank you to you, Jan, and to everyone who engaged in the discussions.
Yeah, thanks for inviting me.
Thank you. And we will be back in 5 minutes.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So welcome back, everyone. This time we have a fireside chat session rather than a lecture. And with me I have Christian Langren. So maybe you want to introduce yourself and why you're here and what you do.
Well, I don't know why I'm here. I think I know why I'm here. I'm Christian. I run a company called iTeam. We help our clients to be more digital, especially through open source software, both using open source, but also using the ideas and methodologies of open source to get our clients to be more agile and also be more part of the future.
Cool. And you've been involved in this öppna skolplattform, or the open school platform that's used in the Stockholm region. Maybe you could talk us through real quick how we ended up here, so to speak.
So the background is that Stockholm has invested 125 million euros in a digital platform called Skolplattformen, and the last 10 years, I think it is. And it launched 3 years ago, and everyone hates it, especially the parents. So it's not done through any kind of user experience research or anything like that. So it's quite annoying as a parent, but also it actually doesn't work at all. So I think it was November last year I decided to do a small scale test for myself to see if I could write something for myself to read my data from my school about my kids, and it actually works pretty good. So I published this code, and a lot of other parents joined. So now it's become a open source movement so, and the story could be quite happy if it's just stopped there, but in January or February, when we launched this app on App Store, the city didn't like at all that we did what we did. So they have tried to stop us, and they have tried to sabotage us, and they actually now filed a police report against us. So now kind of a legal fight for whether or not we have access to the data we actually they publish as open data or not. So that's a very interesting case, and a lot of people are interested in it for many reasons. First of all, parents are interested to see their data of their kids in a better way than that our app can provide. But also a lot of people are interested in this from a kind of open perspective, like how do we envision the society as a whole to be developed? Are we only going to rely on the people working in the government agencies to kind of write the software that are actually a big part of our lives, or should we be able to do part of that ourselves, especially when it doesn't work? So that's a discussion that are really interesting to be part of, and also this case is providing everyone kind of a very clean case of kind of government on one side and the kind of the parents and civic society, but also the tech society on the other side, and the gap between those.
So it's I guess it's sort of a perfect storm, because it's API access and GDPR, I guess, plays in here as well. But technically what you've done is to build a new UI or a new front end on top of sort of the platform that was provided by the city, because the old front end was not good.
No, exactly. Yeah, that's pretty good. So we, from a kind of legal standpoint, you could see our app as being a different web browser. Actually, that we are providing a tool to our users where they can use this tool to see the data that the city provides. We don't have any access at all to the data that this tool is fetching from the city. In the same way as Chrome or Safari or any other browser that you're using, Apple have no access to the data that you as a user of Safari is downloading from the web service. But that's a very technical and legal description. From a user's perspective, it's just you download the app and you get the same data. You log in with your bank ID and it works exactly the same as Skolplattformen, but it looks better.
What has the user reactions been? I guess since you have tractions, it's do you have any numbers, like how
yeah, so directly when we launched, we actually got on the top list of App Store. We on the launch day. It has been quite steadily, actually. A lot of people are downloading it, and right now I think it's 7,000 people or parents that have downloaded the app. But we still expect that it's gonna be much more when kind of this legal battle has settled. I think. So we are, but in the meantime, we are developing a lot of features that our users ask for. So it's I think it's 72 people now, programmers that have joined, and we have a very active Discord. We have a lot of fun developing these things. So it's definitely like a community of participatory development from the actual users.
What kind of features do you build? Since the server-side APIs, I guess, are fixed then, but do you sort of like things differently, or what's the new features?
Yeah, so what we do is kind of we combine the data in a better way. Like if you go to the school platform today, you kind of get very raw dump of the data. It's like you have, these are the activities, these are the newsletters, this is a pager, and you have to scroll through those long list of things. But we try to be a little bit more smart about presenting these things, like to present an overview of all your kids, to see directly when, if you need to remember to bring something to school, like a gym bag or something like that. We provide that information directly. In the old platform, you have to scroll, like go through a lot of different screens and navigations to get kind of to the calendar to see when they start today. We just present that information directly, so you know at a glance if you want to see, like when you stand there. And often when you use this app, you're quite stressed yourselves as a parent. So we do a lot of those things, like be smart at like thinking about the user itself and see at what point is this user going to use this app, and try to be as smart as possible to do that as efficiently as possible. And that's pretty much basic user experience research. And in this case, it's actually ourselves, so that makes it much more fun. You're actually helping yourselves and understanding your own behavior in different things.
Do you build UX for other personas as well, like teachers and so on, or is that?
We plan to. We actually asked the city for documentation of the API, because they have an API that we found when we just started researching this. We asked for documentation so we can also make another app for parents, or for teachers, but also for the kids. But the city, they didn't allow us to get hold of the documentation. So that's one of the legal battles that we want to, that we think that documentation should be publicly available, because that's part of kind of LOU, offentlighetsprincip, and things like that. So after that, we will know if we can do like separate apps for those people as well.
But how are the APIs protected then? So I guess you have a sign-in process somehow. I would guess bank ID being Sweden, but there are no APIs keys per client or something like that then. So
no. So they have a pretty basic, like, standard security model where you log in with bank ID, you get a cookie, and they can use that cookie to access the API. But I don't think that they anticipated when they built this that someone else would use this API. But they don't have any kind of legally binding, or they have no agreement, license agreement, or anything like that that you need to comply with in order for you to use the API. And that's something we have suggested to the city, that they should probably write a documentation, release the documentation, have some sort of agreement that you have to sign in order for you to kind of access the rules of using the API and things like that. That's the normal behavior, and then you get an API key, And as long as you comply with those rules, you can, continue using the API key. And then if you would, if they would find that you're not complying with the rules, they could just disallow the API key to work, and then you're kind of back to the drawing board. And then you can have to go back to the city to be able to use the API. But so that's what we have suggested to them all the time, and that's the normal thing to do. But they have not listened to that, and they are kind of pursuing a different path where they're saying that that what we are doing is not legal, and in different ways that they think. So I think in the end it's about they want to be in control of this development. I think they are not. They have actively said out loud that they're not interested in having medborgardriven utveckling or citizen-driven development, which is, I think, a little bit remarkable from coming from a city that is, supposed to be, serving their citizens.
I saw a question here that's sort of related. So yeah, you talked about sabotaging, and I guess that's changing the APIs. There's a mentioning here of doing small changes just to mess with you and your API usage.
Yeah.
Is that how they counter it technically, rather than just introducing an API key and sort of?
Yeah. So what they did was to kind of mimic how a normal API would look like. So they added a header called API key. But it was static, so you kind of you would use the same API and API key as they did, and I don't think that they actually know what the reason for having an API key, that kind of it's not just a header. But then we used the same API key and tested that, and it worked perfectly for our app as well. And then they continued to kind of mess with these different headers to sabotage our app. We know that the purpose of doing that was to sabotage us. We have seen those letters internally from between those people in the city that decided to try to stop our app. But since we don't have any legal framework to stand on or doing that, then we kind of it's just a matter of releasing a new app with kind of their changes in our app as well. So they tried 7 times to sabotage for us, but now they have stopped. So I don't know right now where they are at right now. But I think that they are probably just waiting for the legal terms to come out.
And is this the administration sort of fighting you, or is it on a political level as well? Or where?
No, it's definitely the administration level. We have pretty good discussion with the politicians. They feel a little bit that they can't really interfere right now until these legal things have been sorted out. But I think from the political level, they have already decided on a strategy for digital strategy, that they are going to use open standards. They're going to use collaborate between citizens and the private business and the city. So they have already in the strategy, and also for for the country as a whole, we already have decided on this path that we need to build these things together. So I would say that these things are only on the administrative level right now. But we will see, and when these legal things are done, we will probably see a lot more development in also from the political discussions, and we hope that this kind of example could also lead to more discussions about the whole society as a whole. How can we use open source software more when developing all our different parts of society, because I think that many people understand that this what has happened here is actually a good thing. That we are parents that have taken on ourselves to help building the society here, and I think that's a lot of energy that comes out from that process. I think that's something we need to do a lot more, because that it's going to be a much better society if we can build together.
I think you had a Twitter discussion with Puff over the weekend as well. Did you start something heading in this direction, like an initiative, or was it just a link that you provided?
A link to what?
As APIs first or something like an
yeah.
in this direction.
Yeah. Yeah, good to mention that. So we have started together with another open or what's it called? It's not an agency, but it's Allmännyttan. They have decided to help the real estate business by using APIs. So we started as a April Fool's joke that we renamed the April 1st to API First Day. So now we have launched this initiative, and we encourage everyone to be part of that, to kind of see and envision a society where we start by defining the APIs between organizations, and then start building the apps and things like that. Because I think right now a lot of people are just envisioning kind of how the app and the websites are going to look like, and then they forget about the information underneath these services. But if we envision like a police and school and all the official agencies and welfare systems more as kind of connections between different APIs at first, and then we can see those app emerges, and some of the apps are going to be developed by the official agencies, but also a lot of apps are going to be developed by private citizens and also companies. So I think that's one part of this. So open source and API first; those are really important.
So I mean, we've spoken a lot about what's happening and those parts, but in an ideal world, what would the outcome be for you?
For this project or for society?
Maybe we start with the project. That's more tangible.
So I think the ideal scenario for this project would be that it develops not only in Stockholm, but it's growing as a kind of a movement between different cities, and also becoming a standard for how we can better communicate between the school and the parents in this first case, but also develop new apps for the kids to be better at knowing what books are they gonna bring to school, and what's important information that they need at a certain point. I think those things should probably be developed for the whole city, for the whole country, because the needs are probably going to be the same for pretty much everywhere. But in the end, I think this is also something that could spread as well outside of Sweden as well. For the Nordics, we've been discussing a lot with Finland, for example. They are interested a lot in open source development, and so I think these type of movements could arise to be much larger than just helping some kids or some parents in Stockholm. So that's what I envision, that we can get that type of open source platforms that are very specific to a certain use case like this. And then also it becomes kind of the vision also for society, that we have a lot of code written in legal language that helps us to regulate how we should move and in kind of the normal society, physical society. But then we also have a lot of code that limits and regulates how we can move in the digital world. And I think that we have a lot more digital infrastructure that is necessary to be built in the coming years in order for us to be more in control over the code that actually regulates our way of working and living in our digital worlds. And if we look at the kids today, they are not going to accept the world that is as it is right now, where you kind of are trusting large corporations, many of them from the United States, to govern how we live our lives right now, and what pictures we're gonna be allowed to publish somewhere, or what language we're gonna allowed to be speaking in different topics, and censoring our free speech and things like that from multiple. And there's a lot of complexity in those questions, and I think we need to be able to have a little bit more control over that. So in order for us to do that, I think that we need to be developing these digital infrastructures ourselves in much more extent. And in order for us to do that, I think open source and these type of publicly funded projects could be the starting point of doing that. So I'm encouraging everyone that listens here that are kind of from the public sector to look at more open source much more rigidly in their procurement process, to understand that if we have now new investments in the digital tools and digital systems, make sure that those are now written in open source so we can reuse them between different parts of society.
Cool. I had one more listener question here, and I'll put an if instead of a can in front of it. But if you get reparations from the legal battle, will you use it for development?
Yeah, absolutely. We will. If we get any money at all from any, and both, and we get a lot of support from our patrons. Right now, the app is still a paid app. It costs 12 kronor. But we want to make it free and instead get support from patrons, and all of that money is about supporting the long-term development of this app. Because right now we can everyone that is involved can be doing that just because it's fun. Because we get a lot of attention and things like that. But in 1 year, when bugs arises and new things happen, we need to make sure that we can sustain this project for a long time. So and I think it's a very important discussion when you're talking about open source, that you're not counting on the kind of the good spirit of good people to always help you out, but actually when there are different boring things to do, you have to have some sort of plan, business model, if you would say, to make it sustainable. So all the money that we get here is going to be supporting the long-term sustainable development of this project.
Cool. And I see we're approaching the end of this half hour. So if anyone has more questions, please shoot. In the meantime, I'd like to just ask you what's the current status? What's the next steps? What's going on?
Yeah, we have a lot of some very important, interesting development now in legal battle. I can't really disclose that much right now, but it's going to be open. It's going to be out there in the next couple of days. And we are continuously developing the app. We have added a lot of new language support. The official app have only Swedish, but there are a lot of parents that only speaks a different language. So that's one of the things. And we have invested a lot in accessibility, so everyone can actually use this, even if you have different types of disabilities. And then we are continuously also looking at different ways of expanding this app to other regions. We have discussions with Göteborg, we have discussions with Helsingborg, with Alingsås, and are looking at different ways of expanding this, because we have developed it in a smart way. So you kind of have the front end in one side, and then we have encapsulated all the API calls in a kind of adapter, which means that we could be able to do the same thing for Göteborg instead, and other places. So we are looking at all those options, but also continuing talking about these different things. We have every Monday evening at 8 o'clock. We have a clubhouse chat where we invite different guests that are discussing the different aspects of this. We have talked about legal aspects, we have talked about UX aspects, and now we're going to talk about growth the next time. How do you grow an open source project like this? We have talked about like data and encryption and security and GDPR and things like that. So every time we talk about the different projects, and everyone is encouraged to kind of go there and just ask questions and be part of the discussion. And also encourage everyone to use this project as a kind of an illustration of where when it's very clear that there are like an old and a new way of doing things, and there's a lot of also like the properties of the new and properties of the old. Like we can do a lot more releases. We can do move much more fast than the old ones. So there's a lot of interesting things, properties of this example. So I'm encouraging everyone to use this as a starting point for discussions.
Cool. I'd like to ask one last question from the audience then, and that's, are you aware of similar initiatives in other cities or countries?
A very good question. Actually, I have not. There are probably a lot of different open source apps and things like that. There's a lot of the recent one here in Sweden is the one that Pierre Mineur was developing for getting seeing the flu shots and things like that. But in the school sector, in open source, I haven't heard anything yet. So if anyone knows, please let me know, and we will retweet that.
Super, great. But then I'd like to extend a big thanks for you taking your time and coming here.
Thank you so much.
I wish you luck in your future endeavors. If
Thank
any
you.
links or so on, drop them on me, and I'll distribute them out through the
Absolutely.
page.
All right, schoolplattformen.org, and please support us at Patreon, and also spread the words and let everyone understand that they can download the app. And thank you so much for having me.
Super, thank you. And we will be back in 4 minutes with the next speaker.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So welcome back. I'd like to introduce you to our next speaker, Italo Vignoli. So please take it away.
Okay, morning everyone. I am one of the founders of the LibreOffice project. Actually, I'm one of the non-technical founders of the LibreOffice project. And I have been in charge of marketing of the project since the first day. And last year we had a quite a large project inside the community, because after 10 years it was time to look at our go-to-market strategy, see if it was working, not working, and we wanted also to improve the project sustainability, because that is incredibly important. So let's start with a few numbers. The first one is about how many users LibreOffice has. So we estimate we have 90% of Windows users, 8% of macOS, and 2% of Linux. Maybe Linux users are a little bit more now because Linux has improved, has grown the market share, but we consider these numbers still as more or less good ones. So we have 100% of desktop Linux users, and or 99.9, but anyway. 10% of desktop Windows users and 10% of desktop macOS users. The global figure is around just over 200 million users worldwide. So we reduce it to around 200 million users. 50% of them are just using LibreOffice. 50% are using LibreOffice and another Office suite. Could be proprietary desktop, could be proprietary online cloud, but is a proprietary one. There has been a lot of discussion about productivity in the last few years, with people saying that productivity is dead, desktop productivity, and cloud is a desktop productivity because the browser is on your desktop. The fact that the engine is in the cloud doesn't change the fact that you are creating a document or you are producing a document. And the attitude of many people was desktop productivity is dead, which is absolutely wrong. So in 2017, last Future of Open Source search, LibreOffice was listed as one of the most valuable open source projects. In 2018, Ubuntu asked its users which productivity tool they wanted as default on their Ubuntu distribution. And as you can see, the answer was overwhelming. LibreOffice was 80% of the answers. So this is 2018, not 2008. So the cloud suite were already established. And we have some market data which are from the Statista website. The origin is an aggregation of analyst data. This is the amount of revenue in $1 million for Office suites. As you can see, in 2021 is $25 billion, or $25,000 million, if you prefer. And in 2025, it will be $31 billion, growing at a rather steady pace of around 5% year over year. So this is not a dead market at all. This is still a market, an interesting market. And the fact that it's an interesting market is demonstrated by the lock-in strategies put in place by the market leader, which is Microsoft. So, which is LibreOffice project model? We have a foundation behind LibreOffice. It's called the Document Foundation. It represents the community. It provides the project governance, owns the trademarks, and collect donations that support the activity of community members. The community is a mix of volunteer contributor and companies, so corporate sponsor contributors. And the community is managing development. The Document Foundation is not managing development. It's just providing the resource for development. The Document Foundation is a not-for-profit, is based in Germany, and of course is not supposed to release commercial software. About Office Suite, they are seen as mature products, and most users see the price as an issue. If you look at Microsoft marketing price strategy, they have tried to go from a one-off license acquisition to a yearly subscription, which has a lower impact on a yearly basis, but at the end has more or less the same amount, is more or less the same amount of money over the usually the usual 3-year life cycle of the Microsoft Office version. There is the advantage that we have now, and people is looking back at Office Suite with interest, is that digital sovereignty, the attention for digital sovereignty is growing at European level and national level in Europe. And people is starting to understand, although there is a lot of sheer ignorance, so people do not understand what there is, the strategies behind the Office Suite, about the document formats and what happens and how the document format can lock you in to the software. So the market has developed, and we are now at the after 2010, when we announced LibreOffice, the situation has been more or less stable. So we have cloud offerings from Microsoft and Google. We have one standard open document format. We have one non-standard, which has been accepted as standard by ISO, but is a non-standard, which is Office OpenXML, the Microsoft Office format. And then there are a few freeware Office Suite. They are either open core or have not a fully open source model. They are clones of, most of them are clones of Microsoft Office. They use the same format, and as such, they just help Microsoft with the Microsoft lock-in strategy. In the meantime, the open source, the amount of open source code has grown, so the attention for open source has increased. LibreOffice stakeholders, community members, they have a very high personal involvement and give a very high value to the project. And we have a very large number of users and which are mostly not involved, and see LibreOffice as a commodity independently from the fact that it's developed by a community and is open source and offers all the advantages of open source. So here you can see more or less in terms of mental perception of the product, where users and where the community are. And this a little bit reflects on other numbers that are especially on donations. So if we look at the commit from Git, developers sponsored by companies provide 68% of all activity on the source code. Volunteers, 28%. 4% is from people employed by the Document Foundation. Is can be code or non-code contribution like localization, but is just a small percentage. Based on numbers, donations are 90% of donations are from individuals and 10% from small and medium businesses. And unfortunately, less than 5% of LibreOffice enterprise users, and we have some very large enterprise users, contribute in any way to the project. And anyway means they can buy an LTS version. They can buy support or consultancy from ecosystem companies to develop features or to solve specific bugs. Anyway, 5% is not enough. 5% is not fair to all the individuals that are supporting with their donations, because we are speaking about companies that are, thanks to LibreOffice, are saving millions of euros or dollars every year from the acquisition, the purchase of licenses of Microsoft Office. Around this issue of open source sustainability is also a growing issue, and there has been some discussion about it. In 2014, the discovery of the Heartbleed bug was the turning point. In 2016, Nadia Egbal published the paper Roads and Bridges. It was sponsored by the Ford Foundation in the States. If you have never looked at this paper, it's freely available as a download, as a PDF download. It's very interesting and has a lot of insight into the issue. In 2019, Dries Buytaert published one specific blog post, but then he invested and published some more, which the title is Balancing Makers and Takers to Scale and Sustain Open Source. And there are a few excerpts in the following slides, and I will make these slides available for everyone. Basically, the last one and the last two is he defines two types of open source contributors: makers and takers, or open source stakeholders, if you prefer. Makers are people that are contributing to open source in different ways. Takers are people and companies that are just leveraging open source without doing anything for open source. The last sentence is very clear. Takers are solely focused on growing their business and let others take care of the open source software project they rely on. So what Dries at the end says is that takers are harming open source project, and an aggressive taker can induce maker to behave in a more selfish manner and reduce or stop their contribution to open source software. And in fact, there are some open source, some formerly open source projects that have changed their license and are decided to choose a toxic license for open source. So they either Redis Common Close license, or MongoDB, Elasticsearch, Graylog server-side public license, or the Confluent community license, or the business source license, whatever. You can look at them in different ways. They may be legitimate in terms of ideas behind them, in terms of attempt to solve a problem, but they're not legitimate as open source. So they have not been approved by OSI because they are not compliant with the open source definition. And then we have the ethical source license, although we may share the idea that open source should be only ethical companies should be allowed to use open source software. The reality is that freedom says that everyone can use open source software, free software. So again, the Hippocratic license is not really an open source license as well. Now let's look at the LibreOffice project. We announced on September 28, 2010. And the reason why we announced at the time is that OpenOffice, the former project, there was a solid risk of abandon by Oracle. And so the community decided to take ownership of, take control of the project and develop a sustainable, a self-sustaining project. So we didn't want to have one single sponsor. We wanted to be self-sustainable. And this was our announcement. The community, backed by several ecosystem companies, takes control to relaunch the innovation and develop a self-sustaining project supported by a solid business ecosystem. So you see, these are the pillars. And the reason why we created a new foundation at the time, there were some people that said, why a new foundation? Is because no one was backing our vision. And so we needed to have a model and status that were supporting this idea. Of course, we wanted also that the ecosystem had some characteristics. So being able to maintain an equilibrium over a long period of time, to be resistant to environment changes, and to be resilient, because of course, especially in a market where you have a competitor like Microsoft, you have to be ready to almost any kind of competitive activity by your opponents. So the Document Foundation is a charitable organization, and we wanted to develop free and open source software based on open standards. So this was our idea. After 10 years, we can say that we have reached our objective. LibreOffice is developed by a combined contribution of community and ecosystem. The LibreOffice brand name is established. So more or less, this is the visual image of where we are now. There is a large community, we have volunteers, we have the ecosystem. There is a very large overlapping between volunteers and ecosystem, because many employees of ecosystem companies are also acting as volunteers inside the project and doing stuff like, for instance, localization of the software, or bug triaging, bug solving as volunteers. Then they're paid to tweak the software, but they are also willing to give some of their free time to the project. If we look at development the last 2 years, as I said, 68% is from enterprise-sponsored developers and 28% from volunteer developers. And if we look at at all contribution in the last 2 years, of course, these are numbers which are extracted from our dashboard. We are improving this. For instance, localization is only partially reflected in these numbers. So the number of people is probably higher in all the 3 segments. But this is what is based on data, not just on speculations. So we have 46 core contributors, 107 regular, and 300 casual. Casual means this is daily contribution. This is weekly, monthly, the regular, and the casual is once or twice a year, 3 times a year. Not really a regular contribution to the project. As you can see, in terms of commit, this 10% provides 78% of commits. And this 66 provides 5%, while the 24% provides 17% of contribution. So if we look at if we can comment this chart number, without the contribution from ecosystem companies, LibreOffice would not die, but the project would not be able to keep up with user expectation of new features, of better interoperability, of improved quality of the software. This would be maintaining the same level of today would be a challenge. So who pays for LibreOffice development? 68% is paid by customers of ecosystem companies. But as we said, the customers of ecosystem companies are just 5% of all enterprise users. And that probably, of course, we are not looking to go from 5 to 100%. We absolutely understand that you need some free users, even in enterprise, because in a sense they help the project. But it would be fair to say that 1/3 of the enterprise users of LibreOffice should contribute to the project. And going from 5% to 33%, there is a 28% improvement, which is rather significant. And 20% of development is provided by volunteers. A large percentage of this is focused on the user interface. Not everything, but a large percentage. And again, the number we are trying to improve how we keep track of localization, because we have a huge localization project. LibreOffice is available in 119 languages, and probably and there are around 150 native language project. Is by far the software available in more languages. No proprietary, no other open source software is available in as many languages. How the ecosystem has evolved. Between 210 and 214, the growth of ecosystem companies was rather significant. We went from 20 to 60 full-time paid developers, but then there were a few years, and these were the years where people would say, oh, desktop productivity is dead. We went from 60 to 40, and now the number is rather stable. The largest contributor in terms of companies to the LibreOffice code are Collabora, Red Hat, and Allotropia. Allotropia is a spin-off of the German CIB company. Then we have other companies. We have a large project in Hungary. They are improving the interoperability because Hungary, the Hungarian government is using LibreOffice, but is also sticking to the proprietary Microsoft Office format, and in that area there is a need of improving the level of interoperability. We had 4 clear development cycles. LibreOffice 3.x was code cleaning, 4.x was code refactoring, 5.x was mostly user interface. Of course, this is just the main focus of the cycle. Is not just 100% of what happened on the source code. And then with LibreOffice 6, we announced a cloud version, Android version, an iOS version. There is now also a Chrome OS version. These are from ecosystem companies, but they are based on LibreOffice. Where are we today? So the community is growing. Unfortunately, the ecosystem is not growing as much as the community. And the relationship between ecosystem and community are not always ideal because ecosystem companies are under stress because of the small number of corporate contributions. The new community members are not aware of where the project started, so they provide enthusiastic contribution, but on the other hand, in some cases, they have an attitude that says, oh, we don't want to have companies behind the project, which is not true, and it's not what we, the founders, we designed as a strategy. And this is the reason why we looked at a new strategy for the next decade. So the LibreOffice project, if you look at it, is positioned exactly in the middle of this figure, because we have a little bit of everything. We have enterprise, we have other large communities, we have enterprises, we have individuals, and it's quite large in terms of extension, which is the unique selling proposition of LibreOffice. It's the best open source office suite ever. This, for sure, first is one of the few fully free open source office suite. As I said, there are some which are freeware. Maybe they have a free version which is not full feature. In order to have full feature, you have to buy, and you have an end user license agreement in that case. We have a strong community and a strong ecosystem. We provide a standard document format for interoperability and digital sovereignty. And we provide also superior compatibility with proprietary document format. And people that say that our support is not good, they should look into how Microsoft is tweaking their non-standard document format to make it difficult, if not impossible, to keep interoperability with that. Probably no one is aware that every 6 to 9 weeks, the format in terms of XML syntax is changing without any warning, without any communication to the user, without any versioning available, without anything, without any documentation on what is changing in the format. What will be happening on the next 10 years? We will use more the LibreOffice technology ingredient brand. So LibreOffice, and I'll talk about it in the next few slides. LibreOffice has evolved from a single desktop product to a platform for development of different software for personal productivity. What makes LibreOffice unique is that the engine is the same for all the version, while all the other software have a different engine for each platform and possibly also a different engine for each application, which means that Word and Excel have a different engine, and they have a different engine on the desktop, on Office 365, and on mobile. So just and every the format is different for each platform, so you can understand which is the mess behind that Office suite. And we will improve our communication around this concept. So as I said, LibreOffice technology is 10 years of development, same processing engine. Source code has been cleaned and refactored. We have a huge focus on code quality and consistency. If you look at the numbers provided, for instance, by Coverity Scan, you will see that LibreOffice has a code quality which is not comparable with almost any other software. We have made available easier APIs. So at the end, this is the best open source platform for personal productivity, and it's tightly integrated on desktop, mobile, and cloud. We have created a web page, and I stress the importance of this image, of this visual. As you see, we have one common productivity engine, one common format, same for all these. So then you have a different user interface on each platform. For sure, you cannot have the same user interface on the desktop and on mobile and also on the cloud. And this is the situation for competing products. So they have a word processing engine, a spreadsheet engine, a presentation software engine for the desktop platform, and they have another 3 for the mobile platform and another 3 for the cloud platform. And each format is different. And then, of course, you have a different user interface. But the problem is that this stack is different from this stack and is different from this stack. So providing full interoperability, full compatibility, full consistency is just impossible. And so we went, as I said, from in 2010, there were only LibreOffice for the desktop. Today, you have LibreOffice for the desktop, LibreOffice long-term supported, optimized for enterprises, LibreOffice Online for the cloud, mobile for Android and iOS, LibreOffice for Chrome. All these products may have different name, but they share the same engine. And so they maintain the same advantages. This is what we did in terms of going from product to platform. We also supported the evolution of the standard. We have a a fairly complex but a fairly complete LibreOffice development infrastructure. This is all provided by the Document Foundation. So we all have these web services are provided by the Document Foundation. And if we look at the time to free open source vulnerability fixes, you see that, and this is more or less reflected in if you look at LibreOffice vulnerability and also in some cases bug fixes. We actually, in the case of LibreOffice, we went the longest we took for us for a couple of vulnerabilities was a month, which means that we always released the patched software before the vulnerability was disclosed in public. This is what has happened to many of our competitors. So they are in this area for quite a large number of vulnerabilities. What we do in terms of document interoperability, this is on the left, you have the original, this is the LibreOffice saved document. We do what it's called round-trip text. We get the document, we open, we change it a little bit, we export, we save it, and we check that everything is preserved. Of course, we do this for all the kind of documents, and we do this on a very large number of documents. Luckily, we have our open document format, which is absolutely the best format for interoperability. There's no comparison in the quality of ODF and the quality of Office OpenXML. Anyone that has a little bit of understanding of XML should open the unzip a Microsoft Office document and look at the XML. And I can tell you that it will be surprised by the it's not even possible to call it poor quality. It's just no quality of XML. So open document format is a really interoperable document format. We have this, as I said, we provide this software, and this software is these are the companies that are providing it. We also decided to differentiate the desktop. We added the community label. It's going to be forever free from TDF. We have to be very clear. Community here is not because enterprise is open core. So community and enterprise have exactly the same features. And there might be cases where a feature has been specifically developed for the enterprise, so the company that has paid for that feature will have a special version for 2-3 months to debug it. But this is the only case where enterprise and the version will not be available for the public. Enterprise could be a little bit different from the ecosystem version. And this is, again, just remember how the community values the software and how the users value the software. So these are the versions, and these are the users which we should use every version. So beta and release candidate is for power users, community is for desktop users, enterprise is for professional users. And unfortunately, what is today, LibreOffice community is supported with donation by individual and small and medium business, and there is a large, incredibly large number of free riders, and only a few 5% are this, which are really supporting the project. LibreOffice Enterprise is a label, is not the name of a product. So it's a family name of different products. What we do to support LibreOffice Enterprise, we have created a business web page, improved the LibreOffice download page, created on LinkedIn, and we are working now at relaunch the LibreOffice certification. So this is LibreOffice in Business. This is the download page. You see business user, click here. And just because there is business user, click here, 10% more are clicking there. Still not converting that into support, but it's a first step. LibreOffice Enterprise LinkedIn page. You are all warmly invited to subscribe to that page. And this is LibreOffice certification. We are just starting to improve this and add steps to certification, make it possible for people to become certified by following a training. Of course, we are looking for testimonial and case studies. We have now a large number of slide decks on our cloud based on Nextcloud. LibreOffice project member, they have materials, notes, they can use a consistent message to present LibreOffice technology. We have just had the first webinar to present the story, but there will be more during the next months. And this is a summary of all the action items. We have a white paper on LibreOffice technology. We have a large slide deck, is I think 200 slides, which is just a very granular explanation of what has happened. We support LibreOffice Enterprise. We are improving certification with specific marketing. And we have started an education campaign. Of course, this talk is one of these actions. We will start with a bi-monthly blog post. I'm organizing a bibliography about open source sustainability. And we will start with interviews and podcasts of the people that are after sustainability. Because there is quite a lot of, a large number of free open source advocates that have written about sustainability. They have different ideas, but of course we support diversity. Our aim is to educate enterprise users about using the right product for their expectation, because we have enterprise users that get the free product and then write on the user mailing list saying, oh, I need this bug solved by tonight. And this is not the right attitude. I mean, it's a free product, and volunteers will decide when the bug will be solved. If you want the bug solved by tonight, you have to pay for some support, and you have different options to pay for that support. And this is what we would like enterprises to understand. And thank you for listening. These are my emails, and you are invited to write me after the event if you have any curiosity about the LibreOffice project. Stopping my screen sharing and going back to my image and to answer question if there is any.
Yeah, hi. Big thanks for a great talk. So I have a few questions here in front of me. One of them comes from the comments here, and it's about the free riders. And you mentioned universities. Do you see? I mean, that was a rollout strategy from Microsoft, at least early on, to provide it cheaply or for free to schools, and then to roll it out. And also, adding on from my side, do you see contributions from there, or I mean, picking up students with lots of free time?
So, of course, the university environment is very diversified globally. So, for instance, in the States, Microsoft doesn't provide anything for free to universities, because universities, students are paying a very high fee to attend universities. And a US university, if using LibreOffice, saves a huge amount of money in comparison. Of course, then you have, in Europe, you have private universities, which are in a similar position to US universities, and then you have state-owned universities. Of course, we do not expect, for instance, Milano Bicocca University, I'm in touch with them, is a public owned, is a state-owned, actually is owned by the region, but I mean, is a community, let's say, community-owned university. We do not expect them to pay for the software. That is okay. We expect them to help us in, I mean, if they use the software, they have 60,000 students. I'm sure they find some bugs. What we ask them, please help us in telling us which are the bugs that you have found, and maybe challenge the students in doing some bugs triaging. It's that is already, that is already a contribution, because it saves time of paid people to work at bug triaging and at testing bugs on different platforms. Actually, in a university, you would find students with Windows, Macintosh, Chrome OS, Linux, whatever. So they can really test the bugs on different platforms with different version of the operating system. So, of course, we are not talking about universities as a global general, but about private universities or universities that buy the product from Microsoft. So if they buy the product from Microsoft, they could buy the LTS version from LibreOffice. The ratio in terms of cost is 1 to 10. So you understand that they would probably save probably not say 90%. Let's say they save 75%. It's a big saving, but that 25% of their initial money paid to someone in the project would help a lot in terms of developing new features and managing bugs. So, of course, universities are not the same. Also, this in a smaller percentage is also for high schools. Most of the high schools in Europe are public, but there are a few private. Maybe there are not so many, but some of them are very prestigious one, like Eton in UK, for instance. Eton, I think you have to pay something like £25,000 per year for a student to be there. And so using LibreOffice for free in this kind of environment, we don't think, and then again, we do not expect 100% to pay, but a little bit more. Or just say, it would be nice just to have an email that says, oh, we use your product for free. What can we do to support you? This would already be a first step. Because in some cases, we can just say you don't have to spend money, but help us with certification, for instance. Help us in promoting the product to students. Tell your students, once you go to the next step of your life, which is you go to the company, that company, if they're using LibreOffice, they should pay for a support or development or something. It's open source is about sharing knowledge, and therefore sharing knowledge is also educating people about the right approach to open source.
Makes sense. Yes. And then also a question here with the business focus that you talked about towards the end. Do you see any risk that LibreOffice will turn into an open core project, or will it only be on the supporting sides?
So let's put it this way. I'm 67. I expect to be alive for the next 20 years, more or less. Until I'm alive and until other founders are alive, you have to step on our corpses before it becomes open core. Then after 20 years, who knows? I mean, the perspective. No, I can tell you that a couple of the companies that are. I mean, Red Hat now is part of IBM, although they have a very strong commitment to open source. When you are on the stock exchange, you never know what your stockholders are asking you. Although I'm fairly confident that Red Hat will stick to real open source and not to open core. But for instance, Collabora and Allotropia, they are small companies or not huge companies, and the people in those companies, and those companies are the ones that benefit from enterprises investing in LibreOffice. They release the software with the same license. So their software, they have a service agreement, which is a different story from a license. So they provide the software with a service agreement, but the license is MPL, LGPL. So they do not want, and they could be the first one to say this is open core because the license allows us to fork it and create an open core. But the idea of the founders was to have a copyleft license. Actually, we do not like too much permissive licenses, exactly because they are too flexible for companies. They allow too much flexibility. And we like very much the fact that if you contribute to LibreOffice, you have to share your contributions. There's no other way. Of course, you can fork LibreOffice, but this is and make your own. But then that would be another story. Would be another software, another project, and but the LibreOffice project will never be open core. I would say for the foreseeable future, which I think it's for the next 15 to 20 years. Then we'll see what happens, because open source now is the software that basically rules the world. It's a little bit too big, but let's say is the reference software for all development. So what is going to happen, I don't know. Companies are investing into open source. Is the Linux Foundation be the same? Would the Linux Foundation be the same in 20 years from now? I don't know. So I think that is fair to say that at the moment there's no risk at all, and in 10 years we will probably have another discussion on the same similar topic and see where open source software is.
Cool, thank you. And then the last question here. So you spoke a bit about interoperability towards Microsoft products. How does products like Google Office work there? Because I guess they have their internal representation, but you can always export in various formats. Are they good citizens, or how do you view it?
Basically, I can say that no one is a really good citizen with ODF apart from LibreOffice and Apache OpenOffice. because they use that format as native. The reality is that if you really use ODF, so if you deploy ODF in the right way, you just give away the control on the format, which means for a company that makes money, you basically allow your user to change the software in a transparent way tomorrow morning. And you understand that if the market has a value of $25 billion, and let's say that you have 60%, which is $18 billion, you don't want those $18 billion go outside your control. This is the reason why they use the format. And I think there are two reasons. First, that is the real control is in the format. Second, is that this concept that the real control is in the format is so unknown to users that users, before they understand that the real control is in the format, it will take years. And this makes the defense of that amount of money easier.
Yeah, it all comes down to locking in enough.
Yeah. But when I talk to people, and I have 3 minutes still. I can tell you
for lunch. You have 1 hour.
No. I mean, it's I don't want to destroy lunch of other people. We are too respectful of food in Italy too. But anyway, I used to run a podcast on open source here in Italy, and in one of these, I was talking about ODF, and I always provide data about it. So I said, to check what I'm telling you, you have to do this and that, and it looked like there were a couple of partners of a large company that did what I said, and then they called the company and said, "Oh, so he is right and you are wrong, and it's 10 years that you are telling us the false." So the solution, the consequence of this is that I don't have the open source podcast anymore, because it was hosted on a platform that was probably closer to proprietary software than to open source software. And that created a little bit of an embarrassment in that large company, because they said, "Oh, but then maybe it's not the only thing where they say the truth and you are telling us the false things." And and this is happening. And when we migrated the army in Italy, we told them, just make a test. You have so many people, take 2 groups. One group is using only ODF, and the other group is using only Microsoft Office formats. And after 6 months, you see which one is better, which one where you don't have any issue, where you don't lose data, you exchange data without issues. And after 3 months, so 3 months before the end, we received a document that says, "We decided to standardize on ODF." And I called and said, "It was 6 months." And they said, "Yes. But after 3 months, we have 1 issue on ODF and over 3,000 on Office Open XML. So we said we think that we don't need the other 3 months to check which one is better." There's no comparison. One, you don't lose a single bit of information, and in addition, the exchanging of data is really transparent. The only issue may be fonts, but you understand that when the issue are fonts, it's such a trivial issue. You just send the free font to the other user and say, "Install the free font," and you can open the document. Okay, so that was a little bit of, anecdotes.
Yeah, but I'd like to thank you for great talk and the anecdotes. It much appreciated. Great having you here.
And good lunch for everyone. I have my pasta alla carbonara that waits me downstairs.
Sounds delicious. Take care.
Thank you.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
Welcome back, everyone. I hope you enjoyed the break. So the talk with Marta will be pre-recorded, but she will be here for the Q&A. And as I understand it, she is also live in the YouTube comments if you have questions. So please enjoy.
Good morning, good evening, good afternoon, no matter where you watch this presentation from. My name is Marta Rybczyńska and I'm a founder of Syslinbit, an open source centric company, and I have been working with big open source code bases for the last 15 years. During that time, I have seen a lot of approaches to entering the code you do not know, and I would like to share some of those experiences with you today. It's foss-north, so I had to start with some penguins. However, we are not going to have a trip to a penguin land. In some way we will, but we are rather going to a jungle of the Linux kernel, and today we are going to learn how to write a Linux kernel driver for any subsystem you choose. When you think about adding to an unfamiliar code, what do you feel? It feels like a jungle, doesn't it? There is some excitement about learning new things. There is some fear because there may be strange beasts hiding somewhere that you cannot see. And there is a lot of things you can look into, you can watch. When entering unknown code, I could notice a number of ways people react. Some of them just freeze in panic, and they do not advance because they do not know where to start from. Some other people start reading everything they can find about the subject. They read all the project's documentation. They read all the specifications they can find. They read all of the examples they can locate. That can take a week, 2 weeks, 3 weeks, or even more. Some other people just start playing with the thing, even if they do not understand it quite well, and they try to find something working. Those are different approaches. Today, I'm going to show you my personal approach. You may have a different one, and I'm going to share with you how I enter a new code base. This has been proven helpful. So let's start. For the presentation of today, I wanted to work with an example. However, when you look into Linux kernel programming, there are quite many examples, in fact. You have books, you have online tutorials, and quite often they cover a character driver. That is easy, but that didn't seem to be something I would like to cover. I preferred to have something a little bit more complex I started thinking about a network driver. Ethernet is something I know very well, so it didn't seem that right to start with something I know very well. I decided to go for a Wi-Fi driver. I've never wrote one myself, so that could be advantage. That could be an adventure for me too, right? Let's look into the Wi-Fi land. That looks like a forest, doesn't it? So first, let's have a look of what we can find around the place when we start a Wi-Fi driver. Most of you will start with an online search about an example driver. I would do that too. It's always interesting to find out what shows up. We can also check the kernel documentation about the driver model. We can check the kernel source code about the drivers using the same type of functionalities. And we can start our plan from this point. We'll cover the first point in a moment. Let's look into what is there in the kernel documentation. First, we do have the driver API documentation, which is quite detailed. We have a documentation of the data structures, callbacks, different fields, what they mean, and how you're going to model your hardware to the driver. And the moment when we'll be in the hardware side of things, when we'll be addressing some specific hardware, that is very, very helpful because we can find the way to represent the hardware features. However, I find that this part of the documentation is quite hard to read as an introduction. However, it gives us a little bit of the information needed from the beginning, which is that there are two models of Wi-Fi drivers. I'm not going to dig deeper into that just today, but that's an important piece of information we need when entering the Wi-Fi drivers. The other interesting part of documentation I could find is the wireless wiki, which is more user level. We have a glossary of the most important terms, very useful when you are just entering the drivers, just entering the Wi-Fi drivers, and you do not know what all those abbreviations just mean. It also has a list of drivers and their status that may be helpful when looking for a driver that resembles the one you would like to write. And it includes information about user-level tools, a list of projects and tools you can use to deal with Wi-Fi. All that very useful. But we do not have an example driver right there, don't we? So, let's now look what we do have inside the kernel. And we do have a little problem here. The wireless drivers are in drivers.net wireless, and you have a number of them I give you an example of the content of one of them, chosen at random. This is a complete Wi-Fi driver, and what we have here, it's 13,000 lines of code, more than 300,000 characters. All the drivers, with some little exceptions, are quite similar. This is a little bit complicated to understand, don't you think? If we were to use that driver as a base of ours to learn about how to write our driver, this could be a little bit complicated to understand, especially that we have to understand that specific piece of hardware too at the same time. So we do have a little problem here. We do have the documentation in the kernel. We do have existing drivers that do work, but most of them are really, really complex. So what to do? When you are starting writing your driver, you do have two paths to it. And both solutions have their advantages and their inconveniences. The first one is starting from an empty file. And then you start adding one function at a time, and you build your driver this way. What happens in practice? That it rarely happens without the copy and paste from other drivers, because you are looking for a specific functionality, you find it in another driver, and then, well, you just copy and paste it, right? The disadvantage of writing a driver from an empty file is that quite often the debugging is going to be quite long, because you may be just missing a little bit and you don't know what we are missing. It means that you will be trying to find out why it doesn't work for some time. And finally, you may know that the Linux kernel internal APIs, contrary to the external APIs that you use in applications, the internals API do change. It may happen that you start writing your driver and you choose an obsolete old API when there is a newer one that is more appropriate for a new driver. This happens when looking into other drivers. You may start being inspired by a driver that is in fact quite old and it wasn't changed to use the new API. There is a risk here, and it may happen that after writing your driver, you will have to rewrite it with a new kernel API. This is what happens when you start from an empty file. You can also do it differently. You can start from an existing driver. The advantage is that you are modifying existing working code. So we could expect that it's going to work and all the changes are by you. If you break it, you should be able to find out rapidly. In this case, you may go through multiple refactoring phases. You change the driver according to your needs, with using different phases, making it work after each phase of this refactoring. The disadvantage we can find using this way is that you will have to understand the code. Understand the basics of the driver you are modifying. It's better if you know the hardware you are taking. If you understand the hardware of the driver you are taking, and it's easier if the driver is smaller, right? So if you are choosing this approach, it's more important to choose the right driver you are starting from, right? You need to choose the right driver you start from, because otherwise you may run into the same type of problems. Like in the first case, you were inspired by the driver with old API, and the same thing happens here. You may have started with a driver using older APIs, and then again there will be things to change. The tutorials for writing Linux kernel drivers usually use the first approach. What I'm going to do today, I'm going to use the second approach. So let's get started. Our first step will be working with an example driver. I've told you before that one of the things we can do when starting looking for information about the new subsystem would be to find an example driver online. Not necessarily one that is in the kernel, but one someone wrote for some reasons as an example, and start working from that. For the Wi-Fi, I did find a blog post explaining how to write a Wi-Fi driver. The blog post is quite long, quite detailed, explaining the structures the author uses, and there is a source code repository related to the driver. So we can try to look into this one. But before we do it, I would like to share with you one secret recipe. I'm using this table to look into a driver to find out if it's a good candidate to use in my projects. And I invite you to reuse this table, or maybe extend it for your own projects. Let's have a look at the categories. First, we have the license. If I'm going to use a third-party driver, it has to have a license that is compatible with my project. If it's a personal project, usually it doesn't matter much. If you are doing a project for a company, you're working for a company, or you're contracting for a company, this has way more importance. You need to have a driver with the right license. Then I try another check with CheckPatch, a tool that is verifying if the patch or a source code file is correct in terms of formal structure, if the coding style of the file is right. The coding style gives us some insight if the driver is close to being upstreamed, or it's some development that is quite far from it. We would expect the coding style to be clear, to be clean, and to be close to what is expected in Linux. Then the third question, is the driver maintained? Here we can use a few things to find out. We can look for the number of commits and where the last change was made. Is it used? We can find traces of the driver being used by different people, but we can also look at the number of patches to the driver and the number of authors. More authors usually means that there are more people using this driver, right? And then, two last questions. Does it compile? Quite obvious, but for the drivers that are not included in the Linux kernel, as I've told you, the internal APIs do change. If you take a driver that is a few years old, it may happen that simply it doesn't compile with your new kernel, or it doesn't compile with your distribution kernel. So this is definitely a thing to check, right? And then I do verify if the driver works. For this, I use a test list. Every time I define what needs to work in a driver, so I could define it as working. For a Wi-Fi, it would mean that I'm able to see the network interface, that I'm able to see the access point for Wi-Fi, that I'm able to connect, and I'm able to send and receive some packets. That's the minimum, and we can have more. Ideally, for each driver type, we'll have some tests written in a scripting language or reusing a test framework, so we can test and see if the driver works. Let's check what it all gives for our first example driver. So, first the license. We can find it in the file, it's all fine. Then we go to check patch, and then we have a surprise. 100 errors for 400 lines of code, that is much, right? So I looked into the details, and it wasn't hard to find. It's mostly the formatting errors, pretty simple to fix. We can fix them without problems, but it gives us an impression that the author didn't run check patch over the driver, what is surprising a little bit. So I'm marking this in orange as something that it's not discriminatory for the driver as is, but it is a warning sign. Then we are going to check if it's maintained. And then for this driver, it has just 2 commits in total, and the last was 2 years ago. So it was just committed at the beginning and nothing happened. So we can say it's not maintained. Is it used now? Not likely, because it's an example driver. And does it but we are going to continue, right? Does it compile? And so that was a big surprise for me. Driver for 2019, and it did compile with my mainline kernel. I was surprised. I was expecting there would be things to change, and no, it did compile. So I told to myself, okay, it's not exactly what I was searching for, but we can start from this driver. We can start playing with it, and we can start learning from this driver, because it is expected to work, doesn't it? As it was published. So, does it work? Well, partially. And let's look into the details. My first test is loading and unloading the driver. So we do it with insmod, in this case, with doing a mod prop of the driver that is required. And what happens is that I get absolutely nothing in the kernel log, so I started looking, and it seemed that it has loaded correctly. However, I do prefer if a driver writes something in the log when it's loading, even if it loaded just fine. Then my second test is to loop removing the driver and inserting it again. There is a common problem in the drivers that the structures are not correctly removed when removing the driver. So it's a common source of bugs. So let's try to remove it and insert again. And in this case, it's passing just fine. So we can continue. Now let's look into the network interface. In the source code, we can find out that it's going to be called Navifly, and it does exist in my system after I load the driver. The interface is up, and the settings look quite reasonable. The only thing I'm a little bit surprised with is the zero MAC address link level addressing. But okay, it's not that important for an example drive. So far so good. Now, the Wi-Fi status. This is something we are going to do with some user space commands. Those we can find when looking into the documentation and learning about user space, command line, Wi-Fi tools. We can list the driver. It is showing a number of information about the channel frequency. Okay, the keys and the encryption keys are off, but we do have the Wi-Fi network name. And well, if we list the Wi-Fi networks, we can find that there is something. However, we have burst at 0 and we have signal at 0. So as if we had a network that does not really work that well, but we do have a network. So I'm going to try to connect. So we can connect from the command line with a command like this. And what happens? That connection activation failed, IP configuration could not be resolved, not available addresses, timeout, etc. So what could it mean? I've never seen that error message before. So I started looking, finding out if there are some packets getting in and out. And then I came back to the driver's source code to confirm what I was thinking about it. I didn't tell you before that when looking in the driver source code, I found some part of the code that looked a little bit strange to me. And let's have a look. This is the function that should be run when the driver will try to send a packet out. What you can see just there is that we have key free. So we are freeing the packet just there and returning that everything is just fine. Absolutely nothing happens with the packet. It doesn't get sent anywhere. So basically my timeout comes from the fact that it cannot connect because the driver is not sending anything anywhere. Now, a little bit of explanation of what has just happened in there. There is a difficulty when writing Wi-Fi driver because you have to connect somewhere. And for Wi-Fi, it's not trivial. You cannot easily do a loopback device. So the person writing this example driver decided to just finish the example here. What makes a perfectly working example, but it's not going to be interesting for my task to having a driver I can use to send some packets. I could have gone further with the driver, adding the new functionalities in it, but that would be writing those functionalities from scratch. With this driver, sending and receiving packets will just not work. We need then to look for other solutions. And in fact, this experience has nothing uncommon when you are taking drivers coming online from different sources. It may happen that the example driver is not exactly what you are looking for. It may not include the functions you want. So we learned quite many things with this driver. And let's look for some better example. This time we are going to come back to the mainstream Linux and have a more detailed look, to locate something we can use for our example driver. I found two drivers that we can use. The hardware simulation, you have the descriptions coming from the key config that the hardware simulation is simulating a network. Okay, that could be interesting. And the second driver, a virt Wi-Fi, yet again a virtual driver, that adds a Wi-Fi driver that is wrapping up an Ethernet driver. That looks interesting. I really wanted to use the hardware simulation driver in this example. However, it doesn't really fit this tutorial. I find this driver very interesting, but that would be another project. Instead, I've chosen the virt Wi-Fi because that's more or less what we need. A driver that is working. In my case, it has Ethernet that I know, so it would be easier to work between the Ethernet and Wi-Fi. But before we enter the driver, we come back to my checklist. This is the version for an in-tree driver with just one additional question. Is it enabled by default? And is it a distribution default? Not all drivers in the kernel are maintained at the same level. There are drivers frequently used that have very high quality, and there are drivers that are used less often by less people on specific platforms only, and we can expect that there will be more issues if we try to use them. This is where this question comes from. Now, let's have a look at the answers for my table. The license, it's okay, check patch. It's quite okay. This one warning is nothing special. However, the driver is not enabled by default and it's not in my distribution, Debian. So it's not that frequently used, it seems. Is it maintained now? We can find from the history that it has been added in November 2018, and since then it has had 11 commits. Last of them was in March. Not that long ago, so it looks quite good. And then we can find commits from 7 different persons. That's not that much, but for 11 commits, that's okay. Does it compile? It does. And does it work? Yes, it does. This time, and I'm not going to cover all of the commands used to make the driver work. I'm just going to cover one thing. This driver is wrapping an Ethernet device. So there should be a way to tell this driver about the other interface it should be using. The thing is, I started looking into the source code and I couldn't find a command explaining how to use it. There was no information in the kconfig neither. So the other thing to have a look is to look into the commit messages. And the first commit message of this driver, it's giving us exactly that. How to use it, how to wrap the driver, how to use the driver with an Ethernet interface we have. So I used that and it worked. In this case, what we get when we list the Wi-Fi's, we get something like that. So we seem to have some signal and some bars, so it looks like a Wi-Fi. And then we connect, and it does really connect. So we do have a working driver that we can use in a system without Wi-Fi. And we can start working from here. So now, how to make your own driver from an existing working one? Here's how I do it. In this case, I've split the Wi-Fi part from the implementation, in this case, the Ethernet. And then after you have that split, you can be replacing that specific implementation with your new implementation using your own hardware. And then after that, you can come back to a single file if you want to, or as refactoring. I'm building the driver as an out-of-tree module because it's way easier to compile and load a separate driver than trying to compile the kernel source. The modification is simple. And I'm keeping copyrights of the original file in the source code. And I note from which file it comes from, because we may be renaming the file later on. So I want to keep the information about what source code we started using for our new driver. Refactoring is an art. How I do it, I do the first commit with my Git repository with the original source code, and I add the out of the tree build. Then I can do differences from this point. Then I do one functional change at a time, and after functional change, the driver has to compile and it has to pass tests. Then I commit. The difficulty is in the first split, right? It takes time, it can be complicated, but it doesn't have to be perfect. You split, and then you can refactor further how you solve it. Because after each step of refactoring, you will know more about the driver. And here's an example of how it looks like after 2 steps, in my case. I do have a makefile, I do have the header file with the common definitions of the data structures that are shared between the 2 parts of the driver. Then the main part is the Wi-Fi port, and the Ethernet port is the Ethernet part of the driver that we will be replacing later by our new implementation. You can see that those ports are of similar size. There's more or less the same size of the both parts of the driver. And an example simple makefile for an out-of-tree build. As you can see, pretty simple, but works. And we are just fine with it for our example. Now, after you have the driver split, you have created an interface between them. You can start adding your own source code and starting to create a new version of the driver with your own hardware. This part, depending on your hardware, will of course have some specific parts that you will have to figure out yourself. But the advantage of this approach that you will be modifying something that works. And you will be able to look into the original driver we took to try to figure out what this particular function will be doing. During this part of adding new code, you may find out that the refactoring was not ideal, and you may want to redo the refactoring a little bit. That's normal. I've done that. We can be changing the split between the 2 parts of the driver also later on. I hope that with this presentation, you have an idea that there is a path in the jungle. There are ways of approaching writing code for a big code base like Linux, but I think that this methodology works for any big source code, be it an operating system, be it a compiler, be it a big library. You can use the same way of approaching finding out information. And at the end, a few of takeaways for you. First is that you can find a lot of online resources. And the first thing I recommend you to do is to check the date. If the resource is very old, it may have outdated information. So it may require you to dig deeper to find out what the current situation is. Sometimes for the Linux kernel, detailed documentation of certain parts is missing, and you may have to take the source code as documentation. And then finally, if there are official resources, they're usually quite high quality. So I'm using the official resources as the first information source. If they do not include the information I need, then I will be looking somewhere else. My second takeaway is to try to have a functional code as early as possible. I have been working from zero a number of times, and it may be frustrating because it doesn't work, and it doesn't work, and you just don't know why. And it may be that you are just missing one single line in your whole driver, but it may take you time to figure out why. Also, over the years, I've learned to run tests every time on every new version of the driver. Because if I make a mistake, I prefer to find it earlier than later. You can say that I'm using a test-driven development for kernel drivers, and that's true. Then, if you follow the refactoring path, your first refactoring won't be perfect probably. So I'm working on a separate Git repository, and then you can do things. You can fold patches, you can redo your refactoring differently later on until you get to your final version. So we do have a path in the jungle, don't we? Before we come to the questions, I would like to thank the authors of the photos I'm using in this presentation. We will be ready for questions now. We have like 15 minutes, so we should be fine. And I'm ready to take your questions or your comments about this presentation. Thank you.
Thank you, Marta.
Thank you.
So we've collected a number of questions from the side here. I think Tobias has them at hand.
I do. Thank you for a nice presentation. It's lovely to see. All right, so the first question was, if I wanted to get into kernel hacking, what would be a good starting point? What would you recommend? I mean, you mentioned that there are a lot of character drivers, so maybe that would be the easier point instead of a Wi-Fi driver. I don't know. I'm not that into kernel hacking. So.
It depends on the person. If you already have experience in some area, for example, working with hardware, or you have theoretical experience with scheduling or memory management, that would be the good place for you to start, because you understand what the developers will be talking about. If you do not have any specific experience, I would recommend to find a subject that interests you. You can start reading about the kernel development, for example, and if you find something that interests you, something that you find cool to work on, then you can start working on it, preferably with a small patch first, of course, and then working on bigger things. They are also, in some kernel sub-projects, there are list of tickets that are ready to be taken by people who start. So if you are in a specific subsystem you're interested in, you can ask the developers, or you can find yourself out if there is that list of tickets for new people, and you can start working on those. Typically, if you ask about the guidance, the work you want to do, you will be well welcome, and you will get helpful information.
Oh, yeah. That sounds great. It sort of makes my second question here moot, but I'll do it anyway. So do most subsystems have like driver APIs that are reasonable, or are there any areas of the kernel that one should steer clear of because they might be too intimidating?
I'm a wrong person to ask this question because I'm a type of a person who exactly enters into the areas of the kernel others people find intimidating, because I like to understand what is happening. They are quite some drivers where there are just a few developers. And those places may be harder to get into because they are talking to each other with their own language. The commit messages may be also in their language. So even if it's in English, it may be complicated to understand. One example of that is BPF.
Oh, yeah.
Quite a popular topic, but every time I look into the code, I find it a little bit complicated, but it doesn't mean you cannot understand it.
And maybe following up on that, are there any specific subsystems that are especially easy to get into, like that are especially well documented, for example?
That's a very good question. Of course, I do not have experience with every single kernel subsystem. That would require a few lifetimes. I have been working in the NVMe subsystem, so the flash drives, and the community is very friendly. I've seen very good reactions to first patches from people in there. There is documentation, there is open specification. So if you have something to add in there, it may be a good start, especially as the hardware is becoming popular. So you have something to work on.
Oh yeah, it's a hot area. Yes. All right. Those were all the questions I had on my end. Do you have any to add, Johan? I don't think we got any more from the...
No, from my side, it's empty on all channels now. But big thank you for your presentation. And I hope we will see each other in person after Corona so we can have a physical event. Thank you.
Well, thank you very much. Welcome. Bye.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So welcome back. Our next speaker, Alex, has also pre-recorded his talk, but will be available for Q&A. So let's watch the talk.
Thank you to foss-north for organizing this event and for the invitation. My name is Alexander Soto. My pronouns are he, him, his. I'm currently an expert in residence at Resilient Coders, and I'm the project lead at EI 2030. Below, you'll find my Twitter handle, Alex Soto Dev, email, our Zulip server, and website where you'll find the slides posted for this talk. A little history. EI 2030 started about a year ago amidst the COVID-19 pandemic, the transition to remote working, and the increased amount of time we spend on our digital devices. The goal of EI 2030 is to promote healthier computing practices, connecting people who are interested in learning, discussion, and facilitating the exchange of ideas and collaboration. We are EI 2030. We are a broad mix of hardware, productivity hackers, health tech enthusiasts, and gadget lovers. Our community is open to everyone, and we are steadily growing. I want to say a thank you to Wenting, Brody, Tom, Anjan, Matt, Manuel, Giovanni. Thank you for your time. Thank you for your contributions. Thank you for believing in a shared vision. This wouldn't be possible without you. We've recently have launched the community-built e-ink laptop project. We are building a proof of concept of an open source and open hardware e-ink laptop. As a community, we'll pull our resources, knowledge, and expertise into working groups. A working group focuses on a specific objective, it's time boxed, they document their process, and also shares resources and knowledge. So we have about 6 working groups. Drivers for e-ink displays, laptop chassis, non-emissive displays, and psychology and UX focus primarily with the objective on the community-built e-ink laptop project, while the low-power MCUs and Paperterm are exploring the possible use cases of an e-ink laptop. So before discussing the challenges of building an e-ink laptop, I'd like you to meet Archer. Archer is our proof of concept of an e-ink laptop. It will enable the early development of our EC firmware and the user software, test the chassis design ideas, verify the circuit design, and also enable future prototypes. So, challenges building an e-ink laptop. So the first challenge is driving an e-ink display. There are about 2 parts when it comes to driving ink display. One is the display controller, or more specifically called the electrophoretic display controller, and also the waveforms. Typically, when you have a company like Dasung or Onyx, when they have a device, they specifically work with e-ink holdings. E-ink holdings provides support with the display controller to make it work with their board, and also provide these optimal waveforms. A lot of this information is proprietary, signed by like NDAs, and there's not really that much information that's available. So our approach is we're going to be creating open source alternatives to build our open hardware and open source e-ink laptop. We're building an open hardware electrophoretic display controller to drive the e-ink panels, and that will enable the creation of open source waveforms that can be used with different e-ink panels. It's going to be hosted on our GitHub account, and in time, beyond the e-ink laptop, what we hope to do is to create a database of open source waveforms that are compatible with a range of e-ink displays that can be used in different projects and devices. So this is a bit of our timeline that's been created by Wayne Thing from the Driving E-ink Displays working group. Sort of started working on the main board, on the chassis, and a lot of the work that's gone into it since late April to about late May and June, and we've just received our board that we're going to be testing. So again, thank you, Wenting. And here you can see the sort of the schematics for our main board and a bit more of a 3D rendering of it. The design files also can be found on our GitHub account. And a little bit more about the specifications of Archer. It's going to be using an IMX 7 Dual. Its main screen is a 10.3-inch e-ink screen. It's going to have a subscreen that's going to be an LCD. And there's also some additional information here as well. And then going back, Caster is the code name for our open hardware EPDC that's going to be using an FPGA development board. It's going to be a M2E or 8 key slot, and it's going to provide one LVDS connector to connect to the EPD panels. And again, some more information about the FPGA development board, and also a block diagram that sort of shows interaction between the main board, Caster, and how that's going to work with the screen board itself. Our second challenge is the laptop chassis. So the e-ink screens that fall in the range that could be used for an e-ink laptop are between 10.3 and 13.3. These e-ink screens use an aspect ratio of 4:3. Now 4:3 sort of stopped being popular or not as much produced, so around 2008 or so. And because of that, it's difficult to find an original design manufacturer that has a laptop chassis with a 4:3 display aspect ratio. Typically, they're now 16:9 that's used for like media consumption and many other reasons. There are not many laptop chassis that are completely open and made with free open source software. So for Archer, we've decided to build our own chassis. And here you can see the picture I showed before, a bit of another close-up that you can see, and one of our initial prints with the keyboard. So we're going to be using open source design, or creating an open source design of a parametric laptop chassis using FreeCAD. And we've started looking at different possible laptop design. It is our hope that by using FreeCAD to design the laptop chassis, we can enable others to remix and adapt our design to their needs. The other challenge is the operating system and applications. There isn't an open source e-ink first operating system, and there are few e-ink optimized applications. There are some examples that we can draw inspiration from. There's a Modita OS that is based on FreeRTOS, an open source e-ink mobile operating system. They have a developer preview where you can sign up. Light OS, it's based on the Android operating system project and uses a React Native app as the default launcher. Then there's also the Remarkable, which uses a custom Linux-based operating system to optimize for low latency with their tablets. Parts of it are available, the bootloader, the kernel, the SDK, but the UI is not publicly available. Onyx Box, or Onyx, and also Dasung. Similarly, proprietary, uses Android, but the UI itself is not really available. So this is sort of the pressing question is, what would a digital device look like that respects our attention, time, and health? The sort of the psychology and UX working group are researching how to create e-ink optimized applications and coming up with the different design principles, performing case studies on the possible psychological benefits of e-ink. And we're also exploring like Android, Fuchsia, and also a minimal Linux distribution. We're looking for software developers and UX UI designers who are interested in building e-ink applications. And then the other piece of the puzzle is sourcing the e-ink display. So e-ink, in order to be able to get an e-ink display, you need to be able to have some minimum order quantity. It's around, last we checked, the number is around 10,000. So, this gets back to our problem of the chicken and egg problem. There's a perceived lack of application and demand for e-ink displays or e-ink devices, and thus there's a lack of suppliers that are producing e-ink displays. We're looking at other non-emissive display technologies like DES, RLCD, e-ink, electrowetting, and the non-emissive displays working group, we've sort of decided is that we're going to be using a 10.3 inch e-ink panel from Waveshare. We're also looking to source different e-ink panels from other distributors like Good Display, and also exploring the use of display electronic slurry, DES, which comes from Good Display. And what's great about this option is that there's no MOQ. So we don't need to fulfill a large MOQ of like 10,000, for example. We can attain however many DS screens that we need. These are some examples of a DS screen and an e-ink screen as well. You can see that there's a bit of a higher contrast ratio, and we're pretty much in the early phases of exploring more using this DS screen. And then our last challenge is the manufacturing process. It's expensive. There's a cost that's involved when it comes to injection molding, the sourcing of parts, the keyboard, the hinges, fulfilling the minimum order quantities. There's very much a kind of domain-specific knowledge that it comes to taking concept or idea, producing it, and then manufacturing it. Mistakes can happen, and it's also time-consuming. So for our initial prototypes, we're going to be 3D printing them, the laptop chassis. And when it comes to producing a laptop at scale, we're going to have to, figure out the injection molding process and the whole manufacturing process. Right now, we're also trying to explore crowdfunding options in the future. We're looking for more people with experience in the manufacturing process as well. So next steps. We want to learn from Archer and work on our second prototype that includes Castor, our open EPDC. We want to iterate on the open design of our laptop chassis and test it. We want to build e-ink optimized applications and identify people who are interested in contributing. Learn more about the manufacturing process. We're going to be applying to the 2021 Hackaday Prize. And we hope, fingers crossed, to do a crowdsourcing campaign in 2022. Again, so if any of these challenges or part of the project interests you, let's talk. Below you can find personal contact information and where to find the slides, and also our Zulip chat. And from me at 2030, we want to say thank you. Thank you for joining us.
Thank you, Alex. And now we're live. So I have a question / suggestion. There was a mentioning of the pocketbook e-readers and their OS and the software stack being open source. Is that something you're aware of?
I haven't looked into the pocketbook. I think when it comes to e-readers, there's a lot of different e-readers that have like an operating system, but that's one that I'll definitely look into. So I appreciate that.
Cool. No, and then there was a question here if there's an alternative hardware-wise to build a tablet instead, and then sort of have the user bring their own keyboard and so on. It would probably simplify parts of the production problems at least.
Yeah, we thought about this. Or I should say, so initially the idea started with this sort of like laptop, and then once we're reaching the laptop chassis part, I'm talking to Wen Ting. I'm like, Wen Ting, why don't we just make a tablet instead? And then he's like, yeah, we could go for a tablet. It would have simplified the chassis part. I think that this is something we want to explore a little bit later. I think some of the resistance I was met with a tablet, at least with some folks in the team, is that at least when some people, when you look at a tablet, you're thinking about using like a Wacom, like you want to give it a draw and touch. It sort of sets a different paradigm when it comes to how you're using the tablet. It would simplify things, but it also increases in levels, I would imagine, with engineering because of the small amount of space you have with a tablet. It's not something I would completely rule out, but I would imagine that by developing the OpenEPDC and also our main board, that could be repurposed, especially depending on the sort of SoC that we use later down the road.
So continuing down the hardware track, I mean, what's the key goal? Is it battery time and the longevity from that perspective, or is it the calmness of the display, or sort of? I used a Pebble. I am appreciated that e-ink display, and it felt very vibrant. But I guess on a bigger one, it's harder to drive the pixels.
So you're saying more or less the objective of the hardware, the goal of it overall.
The goal of it overall, I'd say. So why did you choose to go down the e-ink path and passive displays, so to speak?
So at least for me, as a personal decision, I think that came about when I was both a teacher, when I was working for, when I was both a teacher and also a graduate student. I was waking up about 5 or 6 in the morning, always in front of a computer, teaching 4 or 5 classes, going to grad school at like 5 p.m. and sitting in a 4-hour lecture, not getting home to about 11 p.m. or so, and just being completely exhausted. Some of that could be mitigated by taking breaks and not being in front of a computer screen as much. But I think part of it is also just, a lot of our digital life revolves around these screens, So I think for me, it was a personal motivation to use an e-ink screen. I know other people in the community, part of it has been in regards to, some folks have had like ADHD and in regards to like attention. Some other folks are just into the idea of something like low powered, something that we can use for a very much a specific purpose. So my reason, somebody else's reason will be different, but I think that's kind of what's like uniting all of us here.
Yeah, I mean that's a cool part about open source, that you can sort of join up and handle the common problems together and then do different things with it.
And I think the other part to just like go around that is that the whole part about developing the EPDC and the waveforms that will allow other people in the future to use, to get the EPDC, implement their own waveforms, whatever e-ink panel they may have, and then repurpose it for any other device. So I think by the development of this e-ink laptop, it's not just like the e-ink laptop, the EPDC being open hardware and also developing open source waveforms will enable more use of e-ink devices in other use cases.
Let me just see here. Now that was an answer to the question rather than another question. Some people just want to be able to work outside in the sun.
Funny you should mention that. We have Matt. The whole reason he's like, I just want to give publicity to this project. I just do like mountain climbing, and I just want to be able to take my laptop with me on the go. There's also that group, which is actually kind of sizable. People who just want to be outside and use screens.
But when it comes to OSs, you mentioned a whole range of it. Have you decided on a path there? I mean, the RTOS or full Linux, and sort of that puts constraints on the hardware, I guess, when it comes to RAM and.
Yeah, this is one area that we're still trying to figure out. That and also our system with chip, what we're going to be using. When it comes to the operating system and which one to use, I think when I was going to operating system, I was just more given examples of different sort of e-ink operating systems that exist. I would imagine we first would want to use a sort of like a minimal Linux like distribution. But there are some problems with that when it comes to how the ink screen refreshes. There's a lot of applications that have like a dark screen mode. Yes, you can turn on like a light mode, but that's not exactly like optimized. I think there's more that could be done in that space. So I think we're mostly going to be focusing on creating like using an existing minimal Linux distribution and then trying to maybe optimize some applications. What that looks like yet, I'm not entirely sure. We're still actively trying to find more people who, who's interested in this like challenge.
Hint, hint, nudge, nudge, I'm saying to everyone listening in. You actually answered my next question. It was about the reuse of software and where you see, but I guess that's something you're still exploring there, and what can be reused and what needs to be rewritten. Then I just had a personal reflection over the sourcing. Have you considered collaborating with someone like Pine64, for instance, that are used to doing lower volume sort of consumer grade products?
I'd love to talk to Pine64 if they'd be interested. We're actually, considering, for example, like using like the rock chips. I know rock chip like architecture. I know they're using it in a lot of their like products. Pine64 is one that'd be interested in talking about. I still think we're a bit in the earlier stages when it comes to like the MOQ, but we're getting there. Right now, we're towards our second prototype, and I think once we start getting the EPDC and making more choices when it comes to the SoC that we'll be using, would love to reach out to Pine64. Actually, let me hold that. One of our team members has reached out to Planet 64 in the past, but I'm not remembering all the details of that conversation.
Oh, but you're talking. That's cool.
Yeah.
So that's the end of my question list. Let's give people a few more seconds if they want to add something more. There's lots of suggestions here. I'll leave it to you to read them. All
Okay.
possible games and fun. Is there any last words you want to leave us with?
No, I just want to say thank you. I think in my slides I posted up our Zulip chat, and also where the slides will be posted. If any of this interests you, if you just want to follow along, please join us. We're hopefully trying to be a friendly community.
Super cool. Thank you for being here.
Thank you.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So next up is Rikke, who will talk about Oberon on Risk5. So take it away.
Okay. Hi, everyone. I'm Rikke Solbjerg. I'm a master's student based in Trondheim, currently at NTNU. And last year, I did a project porting the Oberon system to Risk5. So I'll be talking about how that went today, things we can learn from it, some interesting things it had to tell me about Risk5, and what sort of things we can learn from this sort of experience. And I'd like to start by telling you a little bit about both Oberon and Risk5 in case you aren't completely sure about either of them. So I'll start with the one I think more people might be very well aware of, which is Risk5. So a very brief overview. A processor reads your code by fetching instructions from memory. That's fairly basic. And how it decodes those instructions and understands what to do with them is determined by the instruction set architecture, or ISA. So we have a few major ISAs still in play today, and we have many throughout history. And some of the big ones today are x86 and ARM. I'll be using x86 as a quick example because it's fairly emblematic of modern ISAs, in my opinion. So x86 is by now a really old instruction set architecture. It was started in essentially 1978 by Intel with the 8086 processor, and it's been with us ever since then in most Intel chips in laptops and desktops. And instead of doing any major revisions to it or starting anew, which they tried and that didn't succeed, it's instead grown larger and larger with more and more features and more instructions over the years. So by now it's this massive ISA, and if you pick up the manual, it's a phone book. So that makes it really difficult to work with because it's this large. And in addition to that, it's also proprietary. So it has this complicated licensing scheme by now because it's so old. Parts of it are now open, but parts of it are still closed off. So if you want to use something like x86 in, say, education, that's quite difficult to do. You'll have to figure out some licensing agreements if you want to, say, give your students a task to work with it. And yeah, this can be a pretty horrible situation to be stuck in. So as an alternative, some academics at Berkeley got a bit frustrated with this whole issue. So they developed Risk5 as an alternative instruction set architecture. So it's got a couple of nice features I'll briefly mention. It's free, which should be relevant here. It's permissively licensed, and you can essentially do what you want with it. You can write a Risk5 processor and publish it on GitHub for everyone to use and fork and do what they want with. It's also RISC, meaning reduced instruction set computing. So as opposed to x86, which, like I mentioned, grew massive over time with lots and lots of complicated instructions, it's got a small set of basic instructions, and then they're very careful about adding more instructions on top of that to keep it reduced and simple. And the way they do that is by making it modular and extensible. And this will be really important going forward in this port. If you need more features in your target hardware platform, you'll add a couple of extensions to it. So say if you need floating point operations, you would add instructions for that to your hardware as an extension. Whereas if you don't need that, you can target a hardware platform that only has integer instructions and doesn't even have anything like floating points. So that's Risk5 in a nutshell. Next up, the Oberon system. So Oberon is both a programming language and an operating system. So I have attached a screenshot here of what the Oberon system looks like, and it doesn't exactly look like modern operating systems we might be used to today. It actually started in the, sorry?
We still see the Risk5 slide.
I see.
wonder if there's some... Now
better?
we see the Oberon slide. Yeah, there seems to be a bandwidth issue. We can always fix it afterwards and sort of embed the slide set, but just so that you know that the picture didn't change.
Okay, well, thanks for letting me know. That's weird. All right. Anyway, this is what it looks like, and it was started in the 80s by Wirt and Gutenknecht in ETH Zurich. So I've attached an image of Niklas Wirt here, who you might also know as the designer of Pascal and Modula. So if you haven't used one of his programming languages, you've definitely used something influenced by one of them. And here's a quick image showcasing the original Oberon system from back in the 80s, running on a custom Series 3 workstation. Now, Wirt retired in 1999 and started afterwards getting requests to republish a textbook he wrote about the Oberon system, because it described the entire system all the way from the kernel to the UI, so you could read the textbook and understand all of it. But the problem was he couldn't republish it because the computer didn't exist anymore. It was custom built at ETH Zurich, and even more than that, even if you wanted to run it on a different computer, the processor was a National Semiconductor processor, and that company also doesn't exist anymore. So he decided to pick up the operating system itself again in 2013, and this time around ran it entirely on an FPGA using a processor he himself designed and created. So as a brief aside, an FPGA is basically a little hardware thing you can write your own hardware to in a language like Verilog, and you can just flash it to the FPGA, and it will essentially run your hardware for you. So you can design your own processor and actually run it without having to manufacture it. So briefly, what sort of things sets Oberon apart and makes it interesting for a project like this? Well, like I've mentioned, it's supposed to be simple, so you're supposed to be able to understand all of it, all the software. And with this new processor, that one was also made very simple, so you can also read and understand the hardware. The entire operating system is written in the Oberon language, so that includes the compiler, the bootloader, the UI, and the kernel, and all of it. And like I've also mentioned, it has this custom instruction set architecture. So most things today are meant for general purpose processors with general purpose architectures, but he decided to make one that was custom made only for the Oberon system. So nothing else can ever run on that processor unless you really wanted to. So let's start porting proper and start by basically discovering our target architecture for RISC-V. So
I think you need to enforce the slideshow here again.
That's really strange. All right, I'll try to stop my camera and we'll see if that fixes it.
It did. It's a lot sharper already.
Oh, great. Okay. Well, maybe my internet connection is bad then. Okay. Well, let's find our RISC-V platform. So I'll do that by looking at the processor that Wirt designed. And confusingly, that processor is also running what he calls RISC-V, but with an Arabic numeral. So to try to keep them unambiguous, I'll be calling that Wirt RISC-V to disambiguate it from the open free RISC-V, which we're interested in today. So this is Wirt's RISC-V instruction set architecture, and it's a total of 18 instructions, mostly basic ones, a few floating point instructions, and 3 for interrupts. So I figured we'd need some floating point, and we need to work with some interrupts. But then I started looking through the source code for the entire operating system, and it turns out that floating point numbers are never used in the entire operating system. So there's support for them there, but you can have a fully functional port of the system without ever using floating point arithmetic. It's never necessary. And surprisingly, the same also went for interrupts. So I didn't need floating point, nor did I need interrupts for my fledgling port. So at the end, we were left with this really tiny set of 12 instructions that just support very basic computing. And we can't really do away with these two, multiplication and division. Those are pretty essential. We could try to emulate them, but that would be really slow. So we'll keep those, and we'll end up with a platform RV32IM. So that's RISC-V, it's 32-bit basic integer instructions and multiplication and division instructions. So this is a very tiny platform to target. And there was one other choice we needed to make, and that is which privilege modes to support. This choice was also really simple because Oberon has no clue about security. There's no security features in Oberon whatsoever. If someone writes malicious software, it can do whatever it wants. It has access to the entire system. So the M mode here, machine mode for simple embedded systems, fits it perfectly. So let's get on to what needs to be done to do the port proper. First, I wanted to set up a build pipeline. I didn't want to open the Oberon system to compile it all the time. That would be really slow, laborious, and difficult to work with. So I set up something called Project Naribo by Peter de Vacter, which runs Oberon programs in a POSIX terminal. And I tweaked scripts a bit and wrote some extra stuff on top of it. And now with a single command, I could build the entire operating system. So that made the process a lot easier to work with. Next up, we'll get into the port proper. This is essentially a simple flowchart detailing how any program gets compiled and put into the Oberon system. So the important parts for our purposes are these two, the compiler and the linking loader. So we have to port the compiler. We have to make it target RISC-V instead of work RISC-V. That's the major task here. And then we also have to work with this linker, which basically takes the compiled source code and then fixes up some references to other dependencies afterwards. So my hope was essentially I could do something like this, just replace the two of them, and then the port would be done. And we'll see how that worked out, I suppose. So let's briefly look at the compiler. I can't go into every single thing I had to do to make the compiler work and run RISC-V, but I'll give you a couple of examples of the sort of problems that showed up. Because it turns out that even though we're moving from one RISC architecture to another, there's still a bunch of problems that can turn up the sort of thing you might not even think about or expect. So the first problem that showed up was with traps. So when a runtime exception occurred, it has to jump to an exception handler and essentially run some code to deal with that, print why it trapped and where it trapped, so the programmer can go in and debug the error. And in work RISC-V, this is one instruction. It's just a jump instruction, which kind of begs the question, how are we sending that information over to the trap handler? Whereas in RISC-V, we have to spend 3 because we also have to put the information somewhere. So I looked at this a bit and investigated in the compiler, and it turns out that in works RISC-V, there are these conspicuous unused bits in the jump instruction going to the exception handler. Half the instruction is completely unused. And the reason for this is, like I mentioned, the architecture is completely custom made. So essentially, he knew he would need this sort of thing. He knew it would be a lot simpler if he left 16 bits completely unspecified and unused. So he just left them there. And essentially, he puts the why it trapped and where it trapped inside those 16 bits. So he saves a lot of space and makes the program more simpler and more efficient that way. Whereas in RISC-V, obviously, it's supposed to be general purpose. It's supposed to be useful for as many applications as possible. So we don't have the luxury of basically not using half the instruction format. So this is one of those areas where work RISC-V being this special purpose makes it a lot simpler for this specific scenario. Another quick example that showed up that caught me off guard and was really difficult to debug, actually, was in something as simple as an if statement. So this example here in Oberon is essentially an if statement saying that if A is not 0, then lots of instructions will run. So the important part to note here is that within this if statement, there's lots and lots of instructions. And I didn't really expect this to be as big of a problem as it was, but when I looked at it, it turned out that, well, in work RISC-V, the offset for how far you can branch is 24 bits. So that's quite many. And in RISC-V, it's only 12. So doing some quick math there, we can see that work RISC-V can branch over 8 megabytes of code. And no programmer worth his salt would ever write a branch that branched over 8 megabytes of code in most circumstances, I think. Whereas RISC-V can only branch over 2 kilobytes. And an if statement containing 2 kilobytes of code is fairly commonly occurring. That happens several times in the system. So this turned out to be a problem where if the branch was too large, the offset would be completely off and some things would jump back and basically cause lots of weird behavior that was really difficult to debug until I actually figured out what was happening. So I won't go into details on the solution. I basically use jumps instead because they have more bits to jump with, so the problem never occurs. But this was made even more complicated by the fact that the compiler is supposed to be simple. So it's only single pass, it does no optimizations or anything. So I don't even know beforehand if the if statement is too large. So I have to work around basically knowing nothing when this problem occurs. The actual point here with these examples is that things that look like they'd be really simple, going from work risk 5 to risk 5, turned out to be more problematic than I expected. And these are not the only times that occurred. There were several more occasions of this sort of issue occurring. Next up, I'll briefly talk about the linker, or the linking loader, because it both links and loads programs in at the same time, all dynamically in runtime. And the reason I say briefly is because while the compiler took a long time to iron out all the bugs and make it work properly, the linking loader took me about a day, maybe two, to write. Fixing the dependencies is fairly straightforward. Once from one to the other, it's not that different. So this was actually surprisingly easy and a very nice break from debugging a compiler afterwards. So I'll only note one thing, which is that it still gets a lot more complicated because, like I've mentioned several times now, RISC-V is general purpose, work RISC-V isn't. So some of those dependencies we fixing them gets a lot more complicated in RISC-V, and it gets much harder to read. I think the code here speaks for itself more than anything. So, okay, we have the compiler and the linking loader converted from work RISC-V to RISC-V. What about the entire rest of the operating system, like the bootloader and the kernel, the UI, everything? And like I maybe hinted at earlier, it's all written in the Oberon language, which is higher level. So for the most part, I actually didn't have to touch much of this at all. Most of it essentially still worked. I mean, the bootloader is basically just a driver to load stuff from the disk into memory, and that logic is the same across work RISC-V and RISC-V, so I didn't have to change anything. So basically no major changes were needed here. So I'll briefly mention some of the results I found doing this. First of all, I ported this entire compiler, and it is entirely self-compiling. So it can compile itself and then compile other programs. As a result of many different smaller factors, binaries tend to be a bit larger, about 14% bigger than work RISC-V ones. You might have seen some hints as to why that is earlier. Some things take more in RISC-V because it is general purpose. Some programs also take longer to execute. And this is, again, similarly due to it not being general purpose, as some things get more complex. But not by much, and it's not a big performance degradation at all. And some programs actually end up executing faster for various reasons. So finally, I'd like to try and see if this works. I'll try to showcase a quick demo of it running. So this demo will draw a Sierpinski curve when I run this, and then we'll recompile the entire compiler within the system. So that's happening now. You can judge for yourself roughly the speed of this. And then we recompile the Sierpinski curve program, we run it again, and as you can see, it still works just fine. So I'll see if I can get to the next slide. There we go. So finally, what's the point of doing this sort of thing, porting it to RISC-V? Beyond just learning about RISC-V and getting data about RISC-V, which we always need. But the point on a more personal level is that this sort of thing is fun to do. It's fun to work with operating systems and everything from hardware to software. And more than that, it's also very educational to hack on this sort of stuff, to figure it out as you go. I mean, doing this project, I've had to touch everything from RISC-V, emulating RISC-V, the compiler and the linker and everything. So I've had to touch every part of the system while working on this. And as an extension of that, like I mentioned, it's simple. So Oberon is easy to hack on, and I think RISC-V is a pretty good platform for doing that. You learn a lot more doing it on RISC-V than work RISC-V, in my humble opinion, just because RISC-V is a real platform. It's still simple, but it's a real platform, so you'll learn actually valuable stuff about RISC-V doing this sort of thing. But that's only if you can deal, and only if you can deal with the programming language, which to our minds now is fairly antiquated. It was designed in the 80s, and though it's received some revisions, it still feels that way. You get used to it over time, but it's definitely different going from a higher level language to something like Oberon. And finally, there's plenty of stuff you can try to improve while working on Oberon. If you eat your dog food, so to speak, you'll find tons of stuff that really could be improved. And if you try to improve them, you'll probably fall down some rabbit hole figuring it out and learn in the process. And that's quite rewarding. So finally, I'll add some links. I've credited all the FOSS projects I built myself on top of, as well as my advisor, who actually has a talk after me. So I've linked here my port and the emulator, which if you download the emulator, that one also has a pre-compiled image that you can run. And if you run, if you can just play with it yourself without having to do much work beforehand. So I based the compiler on a partial implementation by Semmelfalvo, but that one had had quite a few bugs in it, and I had to fix the linker and stuff as well. So, I built it on top of other previous FOSS projects, which I think is quite fitting. So, thank you for letting me talk. Are there any questions?
Thank you for talking.
All right,
Very, very interesting.
I'll tell you to stop sharing my screen so that doesn't happen.
There we go. An amazing tunnel effect.
All right, great.
There we go.
Hi.
Cool. No, first of all, awesome talk. Like it a lot. So I have two questions here. One is, are there any fun or unusual applications that comes with Operon?
What sort of fun and unusual? Like
something you wouldn't see today.
Oh, sure. Let's see. I mean, a lot of the applications that come with it are basically toy applications. So it feels a little bit actually like downloading an operating system from ages ago, where it comes bundled with a toy program that draws Sierpinski and Hilbert curves and stuff like that. That's quite fun. It also comes with stuff you might expect more, just like drawing programs. Actually, a circuit design program comes with it as well, usually, or at least you can download that. That's not something you find bundled with Windows for certain. Those are the ones I can think of off the top of my head, but you can find plenty more if you Google around for it, I'm sure.
Cool. And the other one is, if you happen to have hardware, what do you need to run it on a RISC-V board? Are there any evaluation boards that you would recommend or things like that? Or
right, so that's something I've been thinking about. We haven't gotten it quite working on hardware yet, just because we haven't put in the time. Mostly because I've been busy with other stuff. So currently, it's mostly tested on emulator. It should work on most evaluation boards, but you would have to make a couple of changes unless you manage to set up exactly like Word did with this. Because, for instance, it depends on an SD card and using a PS2 mouse and so on. So if you use a different USB mouse, for example, you might find yourself having to write a USB driver, which I really wouldn't recommend. Personally, anyway. You might find it fun. But...
And then we have a question here from an Amund. Was it difficult to make the emulator work?
I mean, yes and no. I mostly, like I mentioned, like I think the slide mentioned, I borrowed most of the emulator from Ted Fried's emulator at Microcore. So that's an open source, very simple RISC-V emulator. The biggest problem was there were a couple of bugs in that I actually need to raise issues for, that ended up causing issues down the line where, you have the sort of situation where if something is broken in the emulator, it's really hard for you to tell if the issue is in the emulator or the compiler or the program. So that sort of thing ended up being the difficulty more than just the emulator itself. If that makes sense.
Trust anything, so to speak. You have to.
Yes, exactly. I couldn't trust anything. So.
Cool. But that's the end of the questions that I can see, unless someone's typing quickly. But I'd like to thank you for a cool talk.
Okay,
much appreciated.
All right. See you around. Good luck with the rest of the conference.
Thank you.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So our next speaker is Michael Engel. So please, the stage is yours.
Yeah, thank you. Welcome. And I hope I can tell you a bit interesting stuff about, trying to build your own operating system and hardware. So this talk is entitled Combat Complexity. So essentially it is, it was originally intended as a rant of like, why are our current operating systems so horrible? And you see this note mentioned here. You are not expected to understand this. And this is what happens to me when I look at lots of operating system code nowadays, because even for me, it has become quite a challenge to understand everything. And the question is really, can we do better? So let me talk a few words about myself. So I'm Michael Engels. I'm working at NTNU in Trondheim in Norway as an associate professor since the start of last year. So I got the best of Corona, obviously. Back in the last millennium, I studied computer engineering and applied mathematics, got a PhD on dynamic modification of operating systems code at runtime. And this job I have now is great because I can combine my hacking interests, my research and teaching interests. So on compilers, obviously operating systems, automatic parallelization of code for multicores, dependability of computer systems, and also embedded systems. So how do you become an operating systems researcher? Now, I was always interested, even when I was in high school, in how computers worked down below at the hardware level. And when I started studying, I got really lucky because I got a really cheap Sun workstation. So Sun got some old workstations back from universities, and they sold them very cheaply to us. So my first Unix machine was in 1991, a Sun 360. So essentially, I was a second semester student, and I had my own Unix machine, which was compatible with machines on campus, and that was great. And of course, I was used to things like MS-DOS or an Atari ST before, so I really, really wanted to know how things work inside of this complex Unix system. And of course, it's great if you have your own machine at home. You can just play around with it without, being afraid of breaking something, so all the other 500 students would be mad at you. And that's how all started. And then at university, we actually found another couple of students who were interested in Unix. And so we started our Unix work group. So the picture you see here on the top right is me sometime around 1995 sitting in the room we got from the university in front of one of our Unix machines. Yeah, well, it doesn't look much different today, I'm afraid. And then actually, we got a lot of free hardware that was just discarded by universities and companies around because they heard other students who want to work with Unix. So we got a Motorola system back when Motorola was still building computers with a VME bus board. So this is usually used in industry automation. But this one ran Unix. Now, unfortunately, it ran Motorola System 5.3, which is one of the most horrible Unix systems in existence. And we wanted to do something about this. Now, remember, this was 1993. So a couple of years earlier, there was a person I'm going to talk a bit more about in a bit in Finland who invented this little operating system called Linux. And so we're asking ourselves, could we get this to work on this Motorola VME board? And we were located in Germany, and there were other people interested in this Motorola architecture, so the 68000, who wanted to port Linux to Amigas and also to Atari STs, so all the 68K systems out there. And so we got quite a bit of this going with the help of colleagues, and we also had some meetings, so the first Linux developer meetings in Germany in the early 90s. And then this continued. So a couple of years later, we got donated a couple of MIPS workstations, so by a company called DEC, which no longer exists. And these were also Unix workstations running, again, a different commercial Unix, Ultrix. And this was also pretty horrible. So again, we were asking ourselves, well, can we get Linux to run on this? And yes, we were able to get Linux running on this. So this was, of course, not an effort just of ourselves, but of, well, people all over the world who contributed to this. And we were pretty happy to be supported by the German Linux magazine. So in 1999, there was a big IT expo in Munich called Systems, and they gave us a booth in the so-called Linux Park to demonstrate all our exotic hardware. So we had different machines like PowerPCs and Sparks, MIPS machines, 68K machines, and we could just demonstrate this. And what we didn't really imagine is like all these non-x86 processors are what you find in embedded systems. And so what people told us when they came to our booth at the expo was like, well, we have this processor built in our embedded system like a phone or something. Like, can we just run Linux on this? And we got an idea, and this was a friend of mine, Nicole Färber. She's now the CTO of Pearsm, and myself. And we, in mid-1999, we founded our own company, Kernel Concepts. And I think we were one of the first companies in Europe doing embedded Linux development for customers like Alcatel, for example, building PowerPC-based desktop phones. Well, then a problem hit, and this problem was the first real crash of, well, the dot-com phase. So essentially by the end of 2000, well, most of our customers went broke, and I decided to go back to academia. So I'm now working in academia for like almost 20 years. So I got my PhD and I did research in operating systems, fault tolerance, parallelization. And like at the beginning of last year, I got an offer from NTNU here. So I moved here as an associate professor, and here we're working on hardware-software interaction. So how can we build systems that are more efficient by integrating the actions of the OS, of the compiler, and the hardware? And we're, as Rico already told you in our previous talk, we're doing lots of our research at RISC-V because it's open, it's very convenient, and easy to work with. So why would you want to build your own operating system? So when I tell people on the street like, oh, I'm doing research in operating systems, I sometimes get the reaction back like, what the heck are you doing research in operating systems? Just go out and buy Windows. Well, why don't I want to do this? Well, there's a number of problems. I think most of you are pretty much aware of this. And some of the screenshots here on the right-hand side show typical problems. Nowadays, you have forced updates in most commercial operating systems. This is obviously good for security because, well, even if it doesn't catch 0 days, you can have a security fixed system relatively quickly. But most vendors actually mix bug fixes and security fixes with feature updates. So these feature updates install new features, they change the system in ways you don't like, they use more resources like more processor power, more RAM, a faster GPU. So this will force obsolescence of your older systems, even though with just security fixes, your system would continue to run like you intended to. Some operating systems, especially Windows, obviously force restarts at the least convenient times, like during a presentation or something like this. And there's also sneaking installation of what I call crapware. So games you don't want, some ads showing up in the start menu, or unwanted software like, hey, you got an Edge browser, congratulations, but I don't want one. And in addition, more and more operating systems introduce telemetry. So telemetry is a very nice expression for people, companies spying on you. So an operating system collects data about how you use it, what you use, which programs you start, and they share it with the OS vendor and who knows who else. And finally, well, you've probably all heard about walled gardens. So people complaining, for example, about iOS on iPhones and code signing. So this means that you're no longer able to just run any sort of code on the computer you own, but only code that was signed and checked by the OS manufacturer. Of course, this is also beneficial for security, but if you're a developer, that can be pretty frustrating. I'm running this here on an M1 Mac at the moment, so disabling all the security to be able to run my own software was not a nice experience. So, well, of course, you could say, well, of course, yeah, that's commercial operating systems like that's Windows and Mac OS and whatever. So just use Linux, right? Because, I mean, Linux is out there. So why would I ever want to write my own OS when there's a perfectly good Linux system out there? Now, one of the problems is complexity. So as I mentioned, like, yeah, understanding a current Linux system is hard because it's gotten so complex nowadays. So really, when something, well, happens that you're not expecting, or something doesn't work the way you want it, really fixing problems nowadays takes lots of experience and lots of time. Many of the Linux distributions also come with lots of baggage, so they require relatively current hardware. So if you have some older hardware, you may be left out, then even from security updates maybe. And some Linux distribution vendors also tried something like telemetry or advertising. For example, you see on the right-hand side of the slides here, in previous Ubuntu versions, you had a link to Amazon, whether you liked it or not. You could remove it at least. And of course, well, just with a wink, yeah, it's difficult to find a good Linux distribution not using systemd today. If you like it or not, well, I'm not starting this discussion. So it boils down to choice, security, and privacy. So if you want a Linux system, the best hardware you can still run it on today is an x86 machine. And this means in many cases that you have closed source hardware, firmware, drivers. You have lots of unpatched security problems, like the Spectre backdoors you can get, and the management engine which runs code that you completely are out of control of. So I'd say, and maybe some of you also ask yourselves like, oh, well, let's just try to see how complex it is to build your own OS. And that's what this talk is about, like giving you some links, some inspiration, and well, taking away any prejudices you have, like, oh, this is too complex. So my own OS, far too complex. Yes, if you look at the current commercial OS, this really looks that way. But you've probably all seen that guy on the right-hand side here. Yes, he's Linus Torvalds. And it's almost exactly 30 years ago when Linus announced his operating system project in the CompOS Minix news group. So here's the screenshot of this use post. And he's doing a free operating system, just a hobby, won't be big ad professional like GNU, for 386, 486 AT clones. Yeah, and well, how did Linus actually start with this? So he worked on Minix. So we'll talk a bit about Minix in a bit. So Minix is an educational OS written at the Free University of Amsterdam by Andy Tannenbaum in the 1980s. And there was a great textbook that accompanied Minix, for which you could learn how to write your own operating system for PC clones. Now, Linus started off with Minix, but also he started out with POSIX and System 5 specifications. So the system he actually built was a Unix-like system. Well, obviously. But I would like to open your eyes for alternatives. So the question is, should you create a new OS with like different interfaces, different ways of interacting, different ways of programming it, or should you just implement an existing specification? That's a decision you, well, need to take yourself. So of course, if you implement existing interfaces, you have lots of software which is available. But of course, on the other hand, the complexity might increase quite a bit. So if you have checked out POSIX or System 5 specs, they have like several hundreds of pages. And maybe building a new OS on your own is more fun because you can experiment instead of being restricted to what an existing OS specification would want you to implement. Well, Linus went for building something that very much looked like a Unix system. And of course, well, that was probably part of the success of Linux because there was all this GNU software that was available. So Linus started out building his kernel, and then other people and he himself started porting lots of freely available utilities by Richard Stallman's GNU project. Now, I asked myself, like 30 years later, would Linus actually be able to create Linux today? So let's take a look at the machine, and I hope I got this right. I had to cobble this together from some Usenet posts. So Linus's 8386 machine had a single 32-bit CPU, obviously. It had an ISA bus, which was pretty simple, so everything's manually configured using jumpers for IO addresses and interrupts. It had an IDE disk, or maybe two. It had a PS2 keyboard and mouse, and maybe a VGA graphics card and screen. And I have no idea. I should ask Linus what else documentation he had available. So I checked what was available from Intel for the 386, and I found there's a system software writer's guide that's available on BitSavers as PDF. And that's one book, and it has around 180 pages. So that's something I would imagine that's simple enough to understand. I took a look at it, and it also goes into much detail. So that would have helped Linus quite a bit writing his operating system. I have no idea if he used it. Now, if you look at your current x86 PC, you have many cores, multi-cores, like up to like 64 cores in the current AMD machine. You have multiple sockets. You have different high-speed buses, automatically configuring PCI and PCIe buses. You have different sort of disk interfaces. You have USB, you have Thunderbolt interfaces. You have very complex GPUs instead of stupid frame buffers, which is VGA. You have networking. You have non-unified memory systems. And if you simply look at the current documents Intel publishes for writing code on x86, this is 10 volumes, and this is far more than 5,000 pages. So it would be interesting to know if Linus would really dare to start out writing an operating system for his current nice 64-bit AMD machine he has sitting on his desk. And if you look at the related complexity, of course, it's a question of how much code can you actually manage, for example, as a single person or as a small team. So I checked out the very first Linux kernel 0.01 from 91, and that had around 8,400 lines of code. So that's very reasonable. Not something you would probably write in the context of a master's thesis at university, but something that you could manage, maybe even as a part-time job or in the evenings and weekends. Now, if you look at a current Linux 5 kernel, this has about 28 million lines of code. Of course, there's increased complexity because you have loads of device drivers, loads of different architectures here, but still even the kernel proper. I didn't find a good number for this, but even what makes out the really core of the kernel has increased by several orders of magnitude. So we want to combat complexity. Can we build systems that are easier to understand, that are easier to modify, that are easier to use? And so I have some examples of operating systems, not just quite single-person systems, but I call it just few-person systems, like built on a team of 1 to 3 persons. And Minix is a system I already mentioned at Free University of Amsterdam. So that was built because Andy Tanbaum, who's a now retired professor at VU Amsterdam, was pretty much frustrated about teaching only operating systems theory. So he set out to write a clone of 7th edition Unix. So 7th edition Unix came out in 1979, and he started writing his clone about 5 years later and running on a regular standard PC. Now, there's a project called XV6 from the MIT, and they started out rebuilding and recreating an even earlier version of Unix, 6th edition, which came out a couple of years before 7th edition. And that was more or less a 3-person team, maybe supported by a number of PhD students. There's other projects, like there's projects started out as, I would guess, as hobby projects. So there's a person in Sweden, Andreas Kling, who started to build a system called Serenity. And he describes this as a graphical Unix-like operating system for desktop computers. And I checked it out, and it's amazing how far he got. But there's also completely different systems. And I want to show you a bit about the bandwidth of projects. Like there's a company called Arty, which was mostly Clifford Matthews. And he set out in the 1990s to build a macOS emulator. So you could run macOS software for the classic macOS, so before the Unix-based macOS 10, on a Unix machine. And he open sourced this, well, couple of years ago, and so it's a nice example. It also includes a 68K emulator, so you could run old Mac applications on this emulator here. And all of this was written, well, of course, over the course of maybe a year or more than a year by a very small team. Like the original Unix, by the way, which was written by a 2 to 3 person team if you include the C compiler. But of course, they had like 10 years of development time to build it into a state when they started to commercially market it, which I suppose many of the Unix researchers weren't too happy about. So the question is, if you want to build an operating system, do you want to build yet another Unix clone? And here's another quote by Andy Tanbaum. So after Linus announced Linux on the CompOS Minix group, actually Andy Tanbaum downloaded the code and took a closer look at it. And he found out that he didn't really like what Linus was building. And this is a quote like, "I still maintain the point that designing a monolithic kernel in 1991 is a fundamental error. Be thankful you're not my student. You would not get a high grade for such design." Smiley. Yes. So essentially back in 1991, what many people are doing, like writing a monolithic operating system kernel, was no longer state of the art. So we have very many projects still using monolithic kernels out there, obviously Linux, but also all the free open and NetBSD versions, Illumos as a Solaris version, and also smaller systems like the XV6 we mentioned. We have a 7th edition x86 port from Nordier, and we have some small BSD systems. So maybe if you start out building your own OS, it's time for something new. So try to think about what Andy told Linus 30 years ago. Maybe it's time. And there's alternatives out there. So there are microkernels, which are still a hot research topic, but also used commercially. So a microkernel, for example, is the basis of the security processor in Apple devices. And this is because this can be formally verified, like the SEL4 kernel by Gernot Heiser in Australia. There's Fiasco by the TU Dresden operating systems groups. And there's a large number of microkernel-based projects, which are all open source. So maybe this is an inspiration or even a building block which you can base your OS upon. And there's also systems, and I'll talk a bit more about these, integrating the operating system and a programming language. You've already seen one of those in the Oberon system. Rike gave a number of nice details before. So there's more out there, and I think they might make a nice alternative for building your own system if you plan to do so. So what else could you find inspiration in? So there's a large number of small non-Unix open source systems out there. And I would love to mention two systems first, which we are also working on RISC-V ports here, my students and I. So one is Plan 9, which was a follow-up project to Unix by Bell Labs, which really made everything a file compared to Unix, where you have sockets for network connections and stuff like that, which are not really files, and which was leaner and smaller, and they tried to fix all the bugs and errors in the design of original Unix. A parallel project to Plan 9 based on an early Plan 9 version was Inferno. So this was motivated by the success of Java in the early 90s. So instead of writing all the code in C, Inferno uses a language level virtual machine called DIS and its own language called Limbo. And people who worked on Plan 9 and Inferno, and especially also Limbo, now work at Google, and they were the creators of the Go language, by the way. So there's lots of relations there, and the first Go compilers were actually built and based on the original Plan 9 C compilers. But there's other interesting projects you maybe have not heard that much about. So there's one thing I'd like to mention, which is called the Interim OS, and this is based on Lisp. So back in the 80s, at the previous AI wave, there were custom hardware machines that were optimized to execute software written in Lisp for AI applications, or things considered AI 30 years ago. And these had a integrated development environment. So you could have something like Emacs as a system editor, and then you wrote all of your stuff in Lisp, and stuff up to the hardware side was really optimized to executing Lisp. That really wasn't successful because, commercial general purpose processors, increased in speed and capacities much faster than the guys doing the Lisp machines expected. So, nevertheless, one person in Germany, Lukas Hartmann, decided that it would be nice to see if it would be possible to build a Lisp-based bare metal system running as an operating system with an integrated Lisp language interpreter on top. And he did this for a Raspberry Pi 2. And you can download it, it's open source. And Lukas Hartmann is also the person who created and built the MIT Reform laptop I'm going to talk about in a bit. Another system I also want to mention, because it's not Unix, though it's a bit bigger, is Haiku. So this was inspired and is an open source recreation of the BOS operating system from the late 1990s. It's not that small, but it's very simple. It's based on a microkernel, and it was ported to RISC-V by one person in about 2 months. And I have it running here in QEMU and emulation, and it's really fascinating to see. So there's lots of stuff out there, which is definitely not mainstream, but easier to understand and maybe more fun to work with. And one thing that's also an integration of a language and an operating system, that's Smalltalk. So Smalltalk is a system that was developed in the early 1970s at Xerox PARC, so the research center of that company where everyone thinks they only build copying machines. No, they did really, really lots of interesting state-of-the-art research. And this was running on one of the first systems that featured a mouse, a graphical user interface, object-oriented programming, and even networking back then, using the first versions of Ethernet. And the Smalltalk system ran on custom hardware. This first one was called the Alto from Xerox. And the system was based on a language level virtual machine. It was very small. So the whole system, including a compiler and a graphical user interface, is about 40,000 lines of Smalltalk code. And this is fascinating because it's easily portable, because you can have this virtual machine image that uses only this language level VM instructions similar to Java bytecode. And it's very well documented in that book over there, which is for obvious reasons called the Blue Book, which is freely available for download now. So when it was a rainy weekend and we had Corona lockdown a bit last year in summer, I was asking myself, like, can I get this to run on a €5 Raspberry Pi Zero today? So what's required to run Smalltalk 80? Well, obviously we need some I/O, like a keyboard and a mouse. We need some video output, like a frame buffer. And yeah, obviously we'd also need some disk drive. So essentially we would have to cheat a bit and just build a virtual machine that essentially proposes or pretends to be an Alto keyboard and an Alto mouse and an Alto frame buffer to the VM. And that's what I essentially did. So we needed USB host support to connect USB keyboard and mouse instead of course, the original devices. So this means we would maybe also need to support USB hubs and human interface device protocols for connecting keyboards and mice. We would have to have at least a simple frame buffer and maybe some functions to accelerate it and some way to access files on a disk. Now, there's no real disk drive on a Raspberry Pi Zero. It's just an SD card driver, which is connected over an SPI bus and uses a FAT file system usually. So if you compare the hardware features on the right-hand side, you see it should be easily possible to run Smalltalk on a Raspberry Pi Zero. So this has a 1 GHz ARM instead of an 8 MHz custom processor. It has like 500 times as much RAM. It has a really large SD card, obviously, and it can run high resolutions here. And of course, it's like 4,000 times cheaper than the original machine you could buy in 1981. And so I started off like, I didn't want to write USB drivers myself. I didn't want to write the VM myself because that wouldn't have been a weekend project. And so there's this nice site called Hacker News on ycombinator.com. And I saw a message flashing by like, oh, somebody built an original Smalltalk 80 VM that was hosted on Unix and it's open sourced. And I downloaded it and checked out like, oh, yes, this can really run the original Smalltalk 80 VM image. But of course, it needs the Linux to run below it. So it's a bit cheating, right? Because there's a whole operating system below it. And on the other hand, there was a Raspberry Pi bare metal environment, which provided me with most of the drivers. This was written by Marco Maccaferri, and this included a port of the SDL2 graphics libraries. This included a modified version of bare metal USB drivers, and also a FAT library. So I had all my components together. So sounds like this would be feasible, right? Now, it was, and I brought you a bit of a video, and I hope you can see the video here running. And the first system was working after about a day. I was really surprised. I mostly wrote glue code, and just was relying on all the other code out there. But as you can see, this is a real-time video. It's horribly slow. So that's just one of the demo applications. Similar to the Oberon system, also in Smalltalk, people like to write algorithms that drew nice geometrical figures here. And so that wasn't really satisfying. In addition, we had a number of problems, like USB Zero, Raspberry Pi Zero only had one USB port, which means I could either connect a keyboard or a mouse, but not both. And connecting a USB hub didn't work with the USB code that was actually provided. So essentially, we had a somewhat working prototype after like 2 days, but I wanted to have something more. So I'll show you in a bit how I solved this. But maybe first, if you want to bring up such a system, what can you do? Like if you want to try to get everything to work at once, that usually doesn't work out because there's too many complex interdependencies. So I decided initially to get away without having a file system on a disk, so no disk driver. Well, Smalltalk is based on a system kept in RAM, which is loaded at boot up time. So we have 512 megs of RAM. The initial snapshot image is about 1 megabyte. So we could easily keep it in RAM just by converting the original disk contents or disk file contents into a large array in C code, as you can see on the right-hand side here. And that worked pretty well for testing, but then I found out things like the system hung in the save dialog and I couldn't move the mouse anymore. So the Smalltalk code was obviously correct because it worked in the Unix hosted version. So what I found out that I actually forgot to implement a timer function for blinking the buttons when you actually move over them. But then drawing was surprisingly easy and flexible, so writing device drivers for the screen wasn't really necessary because that was also handled by the SDL. And I could change even the resolution on the fly, which was something Smalltalk supported because it was flexible enough, which the original hardware, which had a fixed resolution, obviously never could support. Well, I wasn't really happy with this, so usually you're a bit perfectionist when you're doing operating system stuff. So I tried to figure out, is there an alternative? And if you want to do Raspberry Pi bare metal operating systems development, I can recommend using the Circle bare metal environment by René Stange. This doesn't use SDL, so you had to set up your frame buffer yourself, but it has updated USB support, SD card support, and even Ethernet, Wi-Fi, and so on. So most of the work doing that port was actually writing lots of glue code. And that's, I think, one of the great things about open source. If you find the right components, you can make your life much easier because writing a fat file system from scratch is not a lot of fun. So if you want to take a look, you can download it from GitHub. You can install it on an SD card. Currently, we run with limited memory due to the 16-bit pointers in the Smalltalk 80 base and a limited video resolution. And there's currently a bug on ARM11 systems. I cannot figure out why it crashes. It's a bit hard to debug, but still, I need to put some more time in it. But I think that's a nice example of what you can do when you have a couple of days left over and actually a nice idea and some great open source projects to base this upon. So you are probably wondering, like, if you wanted to start out writing an operating system, where would you start? Now, there's lots of operating system textbooks out there, and I still like to recommend books. And there's some not that mainstream classic OS books, which don't tell you about how to use a system call or how synchronization algorithms work and stuff like that, but how an operating system works under the hood. And one book that was one of the first books really on writing or describing OS internals was written in the 1980s by, or no, 1970s already, by a professor at the University of New South Wales in Australia, John Lyons. And this was a commentary on the 6th edition Unix operating system. So that's what you see in the lower right-hand photo, the orange book. And the person holding that book is actually Brian Koenig, and so one of the persons involved with original Unix. And he said he learned a lot about the system he wrote from reading the description that someone else wrote about it. Now, this book was never officially published until like 20 years later because it contained proprietary AT&T Unix source code and it described what this was doing. And so it took like lots of time until it was officially published. Inspired by this book were the people by MIT. I already mentioned XV6. So this is a very simple Unix-like teaching operating system, which is more or less on par with 6th edition Unix functionality. And there's also a great book. This runs on x86 and RISC-V. The book I learned operating system internals from is the third one. Here is Douglas Comer's operating system design, the Xeno approach. So Xeno is a recursive acronym like GNU, and it stands for Xeno is not Unix. Yes, it's completely different, but it's a great approach, and he describes how to build a small, multitasking operating system. And there's a second volume even teaching you how to implement networking and TCP/IP. And Rico already mentioned it in her talk. There's a book by Niklaus Wirth about his project Oberon, which you can also freely download. Obviously, there's lots of online resources. I can recommend osdev.org, but There's so many, I can't mention all of them. And if you are wondering about the citation on the title slide, you are not expected to understand this. This was actually from the commentary on the 6th edition Unix book. That was a line John Lyons actually introduced in the code of the Unix system because he was writing this for his students, so they should be able to understand how an operating system works. And this was actually not meant for the general public, but for his students, like, this will not be on the exam. And this is a very classical quote from the Lyons book, which is often misunderstood as like, yeah, this is so complicated, nobody's able to understand it. No, it was just probably his undergrads who, yeah, didn't have to understand this back then. All right. But software alone doesn't really make it, because I can write my software, but I still have to rely on whatever my hardware provider provides me. So are there any alternatives? And you've probably seen that there's a lot of open hardware projects out there supporting Linux or other open operating systems. For example, there's Pine64, which was also already mentioned in the talk about the e-ink laptop. So they have a very nice ARM-based notebook, the Pinebook Pro, which is based on a Rockchip RK3399 core, which is a 4-core ARM Cortex-A53 and an ARM Mali T8060 GPU. So the GPU was designed here in Trondheim by our colleagues from ARM. And they also have an open source phone, the Pine Phone, which runs on an all-winner ARM core. Well, again, a 4-core ARM A53 and a bit of an older Mali graphics card. Then there's the Librem 5 phone from Purism that runs on a Freescale core, an IMX8, this again, and I think you see two patterns starting here, is a quad-core A53, but this has a different GPU by a company called Vivante. And this has a big advantage, at least it had a big advantage until very recently, because it was the only GPU for which open source drivers were available, even though they were reverse engineered. But nowadays, there's also open source drivers for lots of the Mali graphics cards in the Lima project. And there's the MNT Reform notebook. You might remember I mentioned the interim Lisp OS, so that's the same person developing this. This has the same Freescale processor as the Librem 5 phone, so obviously the same hardware features. Now the question is this hardware really open? So can you actually start writing your own operating system without relying on anyone else's code? And the problem with this is what is called blobs. So binary large objects, which is what blob means. So binary code you need to use for firmware, for GPU drivers, for device drivers. And the Freescale-based boards are a bit more open in this respect. Unfortunately, when it comes to Raspberry Pis, which seem to be like open and open source supporting, I like the Raspberry Pi quite a bit, but it's not really open, and the documentation for many parts of the system is still lacking. So will RISC-V help us here? So as Rico already mentioned, RISC-V is an open instruction set architecture. So this means everyone can use the specifications. They're open, they're free to use. If you want to build your great CPU based on RISC-V, you're very welcome to do this. Now, unfortunately, you don't have to publish the source code of your implementation. So many implementations, especially the commercial ones you can buy, are not open hardware. And also the rest of the chip, like all the other things you need to build a computer, like peripherals, bus controllers, memory controllers, they're very proprietary. So very often you don't even get documentation from the vendors about these additional components. So you could write code running on the RISC-V CPU because you know the binary encodings of the instructions, but without a device driver, that won't help a lot. And I have a Beagle 5 board here, so this runs a Sci5 U74 core, and there's other boards which are getting available right now. So there's the Hi5 Unmatched, I think the first deliveries were this week, which also has a Sci5 quad-core RISC-V. And there's a board you can currently fund on Indiegogo, which is the all-winner NESA, that has a Chinese core, the Xuanti, I hope I pronounce this hardware correctly, C906. So the Sci5 documentation, I'm not really happy with at the moment, I must say, because I ported some XV6 operating system code to the Beagle 5, and I found a number of really significant bugs, which you really had to invest lots of time in reverse engineering to get it right. The Xuanti docs are currently not public, but they will be public soon. So they look much more complete. So if you're really interested in getting RISC-V hardware, yeah, these might be your current options, but maybe there's something else going on. So let's get back to Niklaus Wirth, and that's what Rika already told you. So Niklaus Wirth built Pascal and Modular, and he was used to building his custom hardware, like this nice machine on the left-hand corner here, which is the Lilith machine, which was a machine where they even built their own CPU to run Modular 2, and the Ceres machine, which had this National Semiconductor CPU. And he still wanted to teach using Oberon, and these machines were used for teaching at ETH in Zurich. And this hardware was very outdated, so you couldn't get the CPUs anymore, and they were slow. So Niklaus Wirth really set out to build his own system from scratch, and he started by defining his own RISC-V processor. That's where the confusion comes from, and then port his complete Oberon system to run on top of this. And that's what you see running on an old Xilinx board here on the right-hand side. And that might be, fascinating to look, and that shows us it's possible to build a complete system, including hardware and software, running on an FPGA. So, shall we do it like Niklaus Wirth did? Build our own system. So, could I do this on my own? Well, what are the challenges? Until a very few years ago, you had very complex proprietary tool chains. For example, IC and Vivado from Xilinx or Quartus from Altera. And these often required, if you wanted connectivity like Ethernet, to include components which are called IP cores, so intellectual property cores, essentially source code for hardware components that were synthesized. And those were not freely available, so you had to pay to use them. And free versions of these synthesis toolchains were restricted to very small FPGAs, which couldn't really hold very big systems. Now that has changed significantly over the last couple of years. So there's a complete open source FPGA synthesis toolchain called SymbiFlow, integrating a large number of open source projects. And this works for FPGAs from Lattice and some Xilinx FPGAs, and probably more nowadays. I haven't checked. And this really allows you to also have an open source hardware development and synthesis tool chain. And there's even open source boards out there like the ULX3S board here on the right-hand side, which has a rather large FPGA from Lattice and I think 32 megs of RAM, so you can build your own computer. Now, drawbacks using an FPGA is you have a low CPU clock, so you usually are restricted to run below 100 megahertz. Maybe you have little RAM available, so no gigabytes, but only a couple of megabytes. And you still have to fight hardware complexity. USB controllers, DRAM controllers are notoriously hard to get right. So is there an even easier way to build your own FPGA system? Well, let's first look at what some other people did when they were just restricted to a hardware description language like Verilog. There's a nice project called Temlib, and that's one single person who has worked on this for many years, and he managed to recreate a complete Sun SPARC 5, so a machine you see here on the right-hand side, which was introduced in '94, including CPU, RAM, SCSI controllers, color video, Ethernet, whatever you can imagine. And this is actually able to run legacy operating systems like SunOS, NextStep, and also Linux, Net, and OpenBSD unchanged. But this took many person years, so that's not something for a rainy weekend. There's also a large number of other full system recreations. I would like to mention the MIST and MR projects. These are mostly 1980s era 8 and 16-bit systems like Ataris, Apple II, the original Mac, Commodores, Sinclairs, and so on. So all sorts of interesting systems, but maybe, a bit, too not full-featured enough for what you might want to do. Now, luckily, you can build a complete RISC-V system on an FPGA without having to invest months or years of writing Verilog code. So there's system builders out there. So the good thing is if you start with a RISC-V system, you don't have to take care about compatibility. So you can write simple devices which have a simple interface, which make it simpler to write your device drivers. So the RISC-V itself was originally designed in a language called Chisel, which is based on the Scala functional language. And today you can find like hundreds of implementations in all sorts of different languages, from low-level, Verilog and VHDL up to very high-level abstractions. And system builders for RISC-V 32-bit systems exist, and all of these are capable of running Linux if you have enough hardware on your board, like enough RAM. There's, for example, Ultra Embedded, which is Verilog-based. They have a very nice media player demo SoC that can play videos. There's the LightX SoC builder, which is based on a Python domain-specific language called MyGen. And there's Saxon SoC based on Spinal HDL, which is in turn, again, a Scala-based domain-specific language to specify systems. So these might be a good starting point to get a system up and running that you can easily modify, and you can get running maybe on a weekend or so, because you can start with an existing design and then change it to your requirements. So should you give this a try? Should you build your own operating system or even hardware? Like, yes. Why? Well, building an OS and hardware is still challenging. Don't mistake this. It's still a lot of work, and you'll make a lot of mistakes, and even we make mistakes regularly when you do stuff like this. But you'll get a system where you'll be able to understand and modify every line of your code. You can learn a lot about systems programming, so topics you usually don't learn in other courses, like synchronization, communication, virtualization, handling interrupts, talking to hardware, and so on. You'll also learn to be very creative about debugging on many systems, because there's not that many comfortable debugging modes out there for system-level software. You maybe get to know a programming language better, so if you have some knowledge in C or C++, you could use this to write your own OS. You could even use this to learn a completely new programming language, like Rust might be very interesting here. So there's one of the URLs on the bottom of the page is a blog where a colleague in the US, Stefan Martz, actually built his own RISC-V OS in Rust and explains it very well. But most important, and that's also something Rico already mentioned, it's a lot of fun, though of course there are frustrating times when you have to debug stuff. So where would you start? I would recommend starting to develop in an emulator like QEMU or TinyEMU, because this makes it easier to debug. The hardware is a bit more simple. And you don't have to be able to buy actual RISC-V hardware, for example, if you want to target RISC-V, and then target real hardware later. This will give you some nasty surprises, because real hardware is not exactly behaving like the emulator. And then, of course, build the rest, like an SoC, web browser, applications, whatever you can imagine. So you see this very common meme here on the right side, how to draw draw some circles, and then just draw the rest of the effing operating system. Yes, and I hope I could get some of you motivated. And if some of you happen to be students who are just working on their masters, for example, and who are looking to work in research and development and operating systems, actually, I'm hiring a PhD student soon, so we have a 3 to 4 year, depending if you want to do teaching or not, fully funded PhD student position here at NTNU. And I would be interested to work with you on topics related to hardware-software interaction, so new approaches to virtual memory management, systems with persistent main memories, but also if you have good ideas on how to change operating systems, what to make better, get in touch with me. I would be happy to talk to you. So thanks for listening. I hope you enjoyed it a bit, and here's a number of references to books and so on. You might want to take a closer look if you want to build your own OS. Thanks again, and have a good day.
Thank you very much. So I've collected some questions.
Yes.
One of them leads into where you started and what I have here. Do you know of emutos?
Yes, I do.
Good. And you know that you can run it on an Amiga 1200 if you want to have the Atari experience on an Amiga.
Yes, that's really nice. Now, unfortunately, I think the fastest Amiga I own is the 600, and this is still in storage in Germany because I wanted to bring that stuff over last summer, but that somehow didn't work out. Yes, yeah, that was.
I suffer with you.
Yes,
and then you actually Yep, please.
But we have a great computer museum here at NTNU. So for people interested, we have more than 1,000 machines here sitting, and we are planning to restore some of them. So we have some of the old Lisp machines, an old Xerox machine that can run Smalltalk, an Apple Lisa, Norsch data machines I have never heard of, a VEX, PDP-11, stuff like that. So that would be very great to have student projects getting these to work again. Yes.
That sounds really cool. And then you answered my second questions, actually, because one of the things I've seen is various Rust OSs popping up these days. It seems like this linking of programming language or paradigms to operating systems has been ongoing since Smalltalk days, if not before.
Yes, definitely. And the thing is, of course, we all know C has a number of problems, a large number of problems, which are, of course, the cause of many of our security problems. Like I think half of the security bugs we have nowadays are still some sort of buffer overflow. And this is, of course, all because of C really being, intended to be a systems programming language, where it was suspected that the programmer would know what he or she is doing. And that's probably not the case for higher levels of the software stack sometimes. Sorry, I'm speaking as an OS researcher here. So you know this famous saying, applications are just a test load for the operating system.
No, and then the last question is really: do you have any fun operating system that you would recommend as a daily driver?
That's difficult. I'm watching the progress of Haiku for quite some time. Unfortunately, they have trouble really finding developers. I used BOS back in the 90s on a PowerPC machine and even on a dual Celeron machine, which Intel thought was never possible. And that was a fun system. It was fast, it was lean. And we actually have an original B box in our museum I need to get running again. So that was custom hardware built by B in the 1990s before they actually was sold to Palm. So currently it's a bit difficult. So for me, for day-to-day use, I have to use stuff like Zoom and even Microsoft stuff because people are sending all sorts of stuff in proprietary formats. So I have a bad compromise, which is using a MacBook at the moment, I must admit, because Linux has problems like if somebody sends you a PowerPoint or an Excel file, in LibreOffice, it's not always compatible, and that's unfortunate. So no, I probably have to wait until I retire and then write my own OS from scratch, unless I find a number of students who are really interested and help me out with this. So what we're planning to do, if the corona situation allows, I'm going to offer a very unofficial summer course here in August on operating system construction. So that's just a fun course where we could sit together, drink, well, not beer because it's on campus, that's not allowed here, unfortunately, but have some pizza and hack away on some nice project. So if you're close to Trondheim and this works out, well, get in touch with me, even if you're from industry or doing something else. This is open for everyone who might be interested. We have quite a bit of electronics industry here. Like we have ARM here, we have Microchip here, we have Nordic Semiconductor. So I'd like to get more in touch with people working in industry because they all need some sort of operating system for their embedded systems, I suppose.
Really cool. And I'm just checking the comment one last time. So I don't think I've missed any questions from the audience.
Okay, I hope they're not all fallen asleep now, or I scared them off with too much low-level stuff. But I tried to keep it on an abstract level without going into more details. That's what my students can do, like Rika showed, and yeah, I really enjoyed that.
I
So
think
that's
part of our audience likes the details, so don't
Yes.
worry about that.
I think so. Yes, that's what I experienced in like 20 years ago when I gave talks at the very first Linux congresses in Germany we had at the end of the 90s. So that was lots of fun when I was sitting in an audience and I gave a talk about the DEC Alpha 64-bit RISC processor, and I had a T-shirt which was not very nice to Intel, who bought DEC and just killed the Alpha. And so you maybe know this famous saying, "They killed." Bastards, sorry. So they killed the Alpha, and like half of the audience in that hall of 500 people were Intel employees. Oops. But that was fun, and that was what was the liberal aspect of all this open source stuff. I'm missing this a bit because too much has been commercialized nowadays, and I'm trying to get people motivated to really start from scratch, maybe with some new and fresh ideas. But sometimes, we're reinventing the wheel every 20 years in computer science. So now it's time to reinvent all these 1980s and 90s ideas. So maybe we could get something interesting going.
Yeah, let's hope.
Yeah.
Yeah. But big thank you. Really enjoyed your talk.
Yeah, thank you for having me on the conference. And hope to see you all in person next year. All right.
Likewise. Bye-bye.
Thank you. Bye.
Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community.
So welcome back, everyone. I'd like to introduce you to our next speaker, Javier Perez. Welcome.
Thanks. Great to be here. All right. So I understand this is the last session of the event. Been able to watch a few of the sessions. Very interesting. Very, very interesting. So I'm here to tell you about something hopefully you find a little bit different, and hopefully you learn a few things about this presentation. I call it Prepping Your Open Source Project for Multi-Platform. So I'm going to tell you about the different platforms. And I mean, I was just listening to a previous session about operating systems on RISC-V. So there's a little bit of relation. There's a good sequence, and actually before that there was a session about porting, right? So a good sequence, and I'm going to cover all the platforms, and I'm going to cover more of the ecosystem and with some advice there. You know, if I know all of you watching here, listening, are open source enthusiasts, so I'm sure you're going to find a few new things here. But this session could also be for anyone that is not even involved on open source, and I think it will be a good session also to introduce someone to what's happening and what we call multi-platform or multi-architecture. So without further ado, actually, I guess let's introduce myself first. My name is Javier Perez. I'm open source program leader at IBM. I'm part of one of the large organizations within IBM, what is called the IBM Z or Z. I'm originally from Mexico City, and I've been in the Boston area for many years now, getting close to 22 years. I've been in open source for a long time. Lost count, probably more than 10, 12 years for sure, directly involved on open source. Worked for a couple of startups where everything we did was 100% on open source, right? And many, like many other startups, you start with low budget and you want the latest technologies, so open source is the way to go for sure. Early days of Node.js, for example, early days of containers. So we, I was part of a team that I was running product management at the time and building offerings, platforms, SaaS offerings, 100% based on open source. And that brought me to, as part of an acquisition, to Red Hat. I know Leslie was on the first session of this event, and obviously Red Hat being one of the most successful companies within an open source model. We had the opportunity to learn a lot about open source and more about working with some of the communities. And since then, or even before that, I've been working with open source. I went to some of you might remember Appcelerator, run the community and open source program for, and also product management for the kind of the commercial side or the monetized side of the open source Appcelerator project. Very successful project with over 1 million downloads, over 100,000 developers. And then from there, I went to work on security, actually running security for open source, what is called software composition analysis, identifying vulnerabilities in all those dependencies, right, in all those libraries. So, about the scanning, hopefully you know about this, and that will be another session. I have a couple of other presentations about security in open source software. But that's my background. And I'm running this program within the IBM Z organization. And I'll tell you a little bit more about the IBM Z platform in the next few slides. But it's I'm really, I feel myself an enthusiast. I think I'm an advocate and an enthusiast on all things technology, especially if it's open source. So we're really, really happy to be here with you and share something a little bit different. So you have my contact details there. Happy to engage on a conversation with all of you. So I like the next couple of slides is to get you really excited. And I know you already work in open source, or most of you watching this are already in open source. But let me get you motivated, and hopefully, after this event, you say, well, I really like the foss-north event, and it really got motivated to keep doing open source and maybe try a few new things. And look at this, right? I mean, all the innovation today, it's happening in the open, right? You can go to their GitHub repos, you can go to their public repos and see the code out there, right? See what people are doing around augmented reality and virtual reality and autonomous cars and of course, everything related to AI, right? There's a lot of machine learning, deep learning, all what I like to call the building blocks of the latest technologies are all open source, right? I mean, from programming languages to frameworks, they're all in the open, pretty much. Everything it's open source. So we are at a great time, right? And people say, well, it's always a great time. Yes, we are a great time in terms of technology, and those are just some examples there. But as we keep building the communities, the ecosystems of open source software, I think we are going to get even more and more and more innovation. As I said, all the building blocks are pretty much open now, right? And all of you and developers, you've been using open source software, or at least a few open source libraries, maybe not a few, maybe many open source libraries already for many years, regardless of the programming language. And I mean, these are numbers for me are just amazing, right? These are recent. These are just over the last couple of months. There are more than 100 million repositories on GitHub. The stat provided doesn't tell you how many are public repos, how many are private repos. For example, Microsoft, all their employees have a repo, GitHub repo, and many of them keep it private. So we don't have that statistic, but I am pretty sure it's more than 50% of the 100 million that are open. I would say much more than that, and they passed the 50 million developers or 50 million users at GitHub, right? And if you see other organizations like SourceForge that helps you with you open sourcing your project, they have more than 500,000 projects out there, right? I mean, those are people that are serious about open sourcing their projects, their code, and just to give you an idea of how many are they, right? The largest open source foundations, I mean, there are so many, but you look at the Linux Foundation and the Apache Foundation and the Eclipse Foundation, they're huge, right? They have more than they have hundreds of projects that are either incubating or graduating. And I work closely on the Linux Foundation and a couple of projects there. And those are serious projects. Those are projects that already have got traction, that have a large number of contributors, and in some cases, or actually in most cases, have companies that are investing, that are promoting open source. So they assign resources, companies like Google or Microsoft or IBM, Red Hat, and many others, Samsung and many others, that are actually putting money to be part of those foundations, and because they know that those building blocks on those open source projects are the base for their businesses and for also some of their commercial offerings. So millions really of open source projects. And last one here in terms of the introduction, and I hope this gets you excited. I update this slide from time to time. I've been showing a different version of this slide for a couple of years now, and of course everything keeps growing, right? You can go there, the source modulecounts.com, and get the up-to-date information in terms of the number of packages available there. More than 1.6 million on NPM for your JavaScript, Node.js libraries and components, or Python, which is one of the ones. It's actually one of the ones that are growing the fastest. If you see that other number, the number of packages per day, new packages per day, average number of new packages per day. I mean, that's pretty amazing, right? I see that PyPy, so Python packages, Nugget with .NET packages are growing really, really fast, and of course NPM and Maven. They have solid growth. I think from this list, the only one, to be honest, that has kind of a slowdown is Ruby Gems, but all the others were, PHP and of course Java, Python, Node.js, .NET. They just, I mean, you can just find millions really of open source libraries out there. So that tells you where are we. I think it's exciting times on open source, right? Okay, so one of the bases and for the growth of open source has been Linux, right? Linux is really everywhere, and of course it's hard to argue with the success of Linux. And we can have actually a lot of sessions here, panel discussions, and actually presentations about some of the keys for that success. But the bottom line is that pretty much all platforms now, Linux runs on pretty much all platforms, and it could be a Raspberry Pi, like you see there on the screen, that picture, or it could be any other processor architecture. And what you do, as you saw on some of the previous sessions with Spark 5, and actually I'm glad I put Spark there as well, although I was thinking more on Spark. What you have to do at the highest level is, well, you just need a compiled version of that Linux distribution on the corresponding platform, right? And everything else should be very much the same. And all the contributions that are happening on the Linux kernel and Linux subsystem projects, they all benefit everybody else, right? So I know IBM is doing, actually for the last 20 years, more than 20 years now, 21 years, they've been contributing directly to Linux kernel and Linux different Linux subsystems. They are trying to add improvements to Linux that will take advantage of some of the platforms that are using. For example, the PPC 64, which is also known as the power system, or the S390X processor architecture. So improvements on Linux take advantage of some of the features, some of the hardware features of the platforms, but everybody else also benefits, right? You contribute upstream, and then everybody else, and you still have very much the same open source, right? In this case, the same Linux, and then you will have the different distributions, but you'll have the same open source Linux. Well, the same happens then with everything else, all the other software, right? All your code, all your programs. The idea and what I'm proposing here in this talk is, make your software portable, make your open source project portable. By default, obviously, you start with an x86 based processor architecture, right? What you have on your laptop or on your server or on any of the public clouds. You start with x86, but there are many platforms out there as well, right? And well, actually, not that many. Here's a list, right? And I tried to put there just a small piece of a YAML file, and you have to or ideally you build your software portable, right, for multiple architectures, and not specific to a operating system, not specific to a Linux distribution, and of course not specific to a processor architecture. So let's start with x86 and ARM, right? ARM, if you haven't noticed, I'm sure you have. It's everywhere now, right? This RISC architecture with the reduced instruction set, it's taking over, and it's taking over because it's more affordable, or it's the cost is lesser cost. There's less number of transactions. That's why the tasks happen with the fewer clock cycles. So a reduced set of instructions consume less energy, less power, and and that's why you can put it at a small piece on any small gadget, right, or any small device. So some of the pictures that you see there, actually all the pictures you see there, are for ARM chips or processor architecture. And if your software runs on x86 and say, well, I want to do it on ARM, or I want it also to make sure that it runs on ARM. You saw in a previous session about RISC and some of the details on the compiler, and I need to go back and watch the whole session, but I catch the final part, and I know for a fact that it was obviously on the details of some of the issues with the compilers and things like that. Well, the good news now is that pretty much all compilers have been ported to the different processor architectures, right? Pretty much all the programming languages and frameworks have been ported to the different processor architectures. So you don't have to deal that much with that lower level. It's already there, but you have to port your software, right? If you want to make it, in this case, work on x86 and ARM, at a very high level, what you do is you build your software. You take the same code, you build it or compile it depending on the programming language, and then you deal with some of the, if there are issues at the time, or there are errors at the time of that compile or that build, right? And of course, very, very important, and you'll hear me saying this a few times, you have to do that. You have to pay attention to the dependencies, right? To all those libraries. Correlation with the previous slide in terms of the number of libraries. Yes, so for example, JavaScript and Node.js, you use a lot more dependencies, right? You see that projects have not one or two, but actually sometimes hundreds of dependencies of other using other libraries, which they use other libraries, which use other libraries. So the full chain of dependencies in terms of the libraries. If you are coding in Java, you still have a lot of dependencies, but it's much less than when you compare, for example, with JavaScript or Node.js. So obviously you have to pay attention to that while porting from one processor architecture to another. S39EX, and I'll tell you a little bit more about this, because I found it like not a lot of people know, or some have a misconception or an old kind of image of the S39EX processor architecture. As you can see on the picture there, that's the processor architecture that runs what is commonly known as mainframes, right? IBM Z or IBM Z or IBM Z. It's the brand of those quote unquote mainframes that have been around since the 1950s, right? So for a long time, but they keep evolving, right? They don't look like that. They look like the picture that you see at the bottom. And that's one frame, and you can have 2 or 3 or 5, even 4 frames, or you can have access it through a cloud, right? But this has been decades of innovation. So things like work isolation has worked for decades now, right? Now what we hear now in terms of public clouds, things like well, I have a multi-tenant platform or multi-tenant cloud, and that's workloads isolation, right? So those are concepts that had on the S39EX architecture for a long time. The same goes for virtual machines, and the same goes with the use of containers. Not to mention, the focus on security and encryption and compressions and other technologies that they're more on the news today, right? In terms of cybersecurity and encryption and security. That's been going on for decades, and that's one of the reasons some of the largest mission-critical applications run on this platform, right? Pretty much most of the banks, much of the financial institutions, in governments, in reservation systems, credit cards processing. It's all based on this architecture, on these platforms, right, which offer really high level of availability and disaster recovery. Same goes for encryption, addressed, in use, and even REST in transit and even in use as well. So there's some interesting technologies out there. But the good news is that Linux runs on these processor architectures, and that has helped to grow the open source ecosystem, right? I'm not here to talk about much more about the hardware, but I'm so amazed with this statistic. So I said, well, I have to share this, right? Just for some people to like myself to kind of appreciate the power of this processor architecture. So a couple of stats there. I mean, you can read through the bullet points, but one of this, just one of like the high end, can process up to 1 trillion. Yes, 1 trillion HTTP transactions in one day. I mean, web transactions in one day. It can compress data, 275 gigabytes of data per second. So those are amazing numbers, right? And tells you why this type of platform it's out there. It's out there in the some of the largest financial institutions and organizations. But that's just one thing, right? Everything else is software, and everything is those building blocks are open source. So I'll tell you more about this, and then at the end of the session, I'll give you a link to. You say, well, I'm not gonna be impossible to buy one of these. Well, they're not as expensive as the money that companies and especially even startups are paying for public clouds per year. They are actually paying a fortune to the public cloud services, right? The offerings, but that's another discussion. But I'll say I'll at the end of the session I'll give you a link so you can go and give it a try. Which it's just all based on Linux. I have another session to talk about the history of open source, and I know I'm sure people in the audience like to know more about the history. I'm just going to highlight one thing, and it actually relates to this S390X platform. There's an organization called Share. That Share organization started in 1955. With a group of users of at the time the mainframe, the IBM 701, and it actually started in California. And these users say, well, why don't we just start talking about what we do so we can learn more, right? And those are the concepts of open source. And they started with basically a public library. They say, well, we can share what we've been doing here, right? This is back in the years where it was just all pretty much hardware, and the hardware will come with the software, right? But that's, although it was not known as open source, the fact that they were sharing the software, they were distributing kind of from a public repository or public place the software. I mean, really that you can track it as the beginning of open source back in as old as 1955, right? And then in the late, and actually in the fact of 1999, that's when the first installation of Linux happened on the S390X platform. And it's been now more than 20 years of growing that open source ecosystem, right? And most of the installations today are not on proprietary software, on proprietary operating systems. They're on Linux, especially the largest enterprises. More than 90% are all running on Linux. So here's a sample of all the open source software that you can find in this platform, right? And what I'm going to talk to you on the next few slides is some of the steps that pretty much all these open source projects or all these communities have followed to make their software available on S390X, on ARM, on x86, and maybe other Spark, or maybe other processor architectures, right? And actually, this doesn't cover everything, of course, but I kind of put it together as like some of the most recognizable open source software out there. And it's obviously, they're very large. It's amazing, as I was saying at the beginning, right? How much open source software it's out there. So when you're looking at preparing your project for multi architecture, you have to look at your test cases, right? So, and this is, you'll say, well, this is common sense. I put together these slides, or the next couple of slides, just based on the experience that our teams have done, and they're doing it for, as I said, for over 20 years in the case of IBM, right? And you go choose your test cases, right? That go and before you're going to be doing the porting, you're probably going to be spending more time on the testing than actually porting or doing any modifications in your code. So choose your test cases, analyze the performance. You don't have to go into too much detail, but have a good idea of the performance of your software, and then plan to do some scale that test, right? So when you have your software on two platforms, let's say x86 and ARM, or x86 and S390X, so you can compare the performance. The porting part is for some of the languages, it's actually the easy part. You just have to make sure that the performance is there. And in some cases, once you're done with the porting, then you can focus on optimizations, right? Especially kind of mathematical instructions, some of the libraries that do some of that work. That makes sense to optimize them, take advantage of more horsepower that you might have on your new processor architecture, or the processor architecture that you want to try, and kind of optimize, enhance your software, right? But you just start the reporting with just building or compiling your package, right? You also want to do it for multiple Linux distributions, right? So a good successful open source project runs, or you support us with your community supports, different distributions. For the most part, there are no changes or minimum changes that you have to do to try and even just make the binaries available for the different Linux distributions, right? And again, obviously, you have to pay attention to the dependencies, because everything applies again and again and again for those libraries. So in terms of the scope, most programming languages and compilers, as I said, have been ported already, right? So obviously, as you saw in the previous sessions, you can also focus on your own operating system, and you can go into more low-level detail. But you have your open source software. You want to make it multi-architecture, multi-platform. The advantage is that most of the programming languages and compilers have been ported already, right? So you don't have to deal with that. There's availability there. Depending on the programming languages, some of them is easier than others to port. And actually, the word is not easier. The word is less probably time consuming than others, right? So obviously, compile languages, you have to compile your software, especially if C++. You might be working with more low-level memory allocation, and you might have to go and change a few things. And I'll tell you in just a second some of that. So that's what could be a little bit more time consuming. For interpreted languages, it just runs, right? They run independent of the operating system, so require really minimum or really no changes. We've seen a ton of Python libraries that you just have to build it and it runs. It works, no changes, nothing, right? So you automatically have your open source software multi-platform, or at least available for the ARM or S390X without much effort other than you just build the software, right? One of the tricky parts, and that's part of my job, is to work with some of the communities and say, hey, it's there, it's available. Actually, I didn't have to send you any pull requests because I didn't have to change anything. It just runs. I can provide you with some documentation of how I did the build, but why don't we put this build on your CI pipelines, right? Why don't we just make it just automate this, and your open source project will be available for these other platforms, and that's going to be good. You're going to be able to tell that your open source project is available in different platforms, right? That will open also the user base and the developers that are using the different platforms. So we've been successful, and you saw all the logos on the previous slide. We've been successful with many open source projects, and that's the ideal, right? Not just do it every time you need to port it, but make it even part of the CI process, making part of the CI pipelines, and make it available to everyone, right? Make it easier for everyone. A couple of other things there when you're doing your multi-architecture porting, and again, this applies to any of the processor architectures. So obviously you'll have to, when it's building or compiling and it has some errors, you have to, in some cases, just you debug that, and in most cases is just tweak a little bit your scripts. Sometimes they might be trying to use a library that is specific to the architecture. So in some cases you can just disable that or comment that or just remove the library, and it just works, right? And something that might not be important for the functionality. I've seen a lot of that. In some cases, yes, you just have to go and make some small updates. Obviously, I mentioned earlier, very important to do the feature parity, so making sure that everything works on the 2 or the 3 or the 4 architectures that you're going to do your multi-architecture project. Obviously, you have to test, and then the key part here, if you are making changes, obviously you want to go and send the PRs, right? Contribute upstream, and then everyone benefits of that. For the most part, communities are open to accept pull requests for the when you are upstreaming your changes or small changes, which that's the other thing, right? Depending on the programming languages, in some cases they're very small updates, so easy to review and say, well, yes, I accept. As a maintainer, the maintainers go and accept those upstream contributions, and now you are multi-architecture with that, a lot of effort there. And of course, you play nice with the communities, as you know, and you offer to provide some of the scripts or provide some of documentation, right? Which is always important. So you probably heard this many times, right? We have contributors. Not all are developers. You can always contribute with documentation, with design work, and that's part of that, right? So if you want to make your open source project available in multiple architectures, I would highly recommend not only to upstream your code if there were any changes, but also contribute with your build instructions, for example, just documentation of how to build the software. For S390X specific, there are it's actually one consideration, and I think some of you, if you have a computer science background, you remember the Little Endian and Big Endian memory allocation, right? So that's the only really technical difference. Well, I mean, we can go in detail, and obviously there are many more, but at the high level, that your ARM or your x86 software will be used in Little Endian, whereas on S390X, it's one of the few that remain Big Endian. Although, it's not the only one, but there are more out there. But kind of like, I know some of the Mac has been using Big Endian as well. But S390X is known for the Big Endian memory allocation, right? And that has to change. Again, not just for your software, but also on the dependencies if they're using that functionality. And for the most part, and I don't have it here, but the error message, it actually tells you that it's about Little Endian or a Big Endian error message when you are running, you're building or you're compiling your software, right? And so let's talk about that for just a second. And in case that you don't recall this from your computer science courses, it's about the endianness, right? Which is about describe the byte order, right? Where you put your most significant byte versus or your least significant byte, which one you point first, right? So Big Endian is the most significant byte is stored first, whereas on Little Endian, least significant byte is stored first. And you can see there on the image, it's just the reverse order. Processor architecture, like as I was saying, like S390X, Spark, and a few others are on Big Endian. the most known or used processor architectures like x86 for 32 bits, or x64 for 64 bits, or ARM64, or PPC 64 are using Little Endian. Actually, PPC 64 LE stands for Little Endian. And this is how you deal with it. Well, first of all, if the software works, if the software, so the software is going to work without NDNS issues if there's no explicit memory access, right? So you don't deal with low-level memory allocation, then you don't have to worry about that. There's not going to be a problem. Or if there's no data exchange with other software. So when there's data exchange, obviously very important to have the correct byte allocation, right? So the idea here, and we've seen it with many open source projects, use all those logos and more, is to make it available for both, right? It's not just, all right, I'm going to fork my open source project and I'm going to do it for Big Endian. No, the idea is to support both Little Endian and Big Endian. It's actually not a big deal. What you do is a byte swap. You use a byte swap function. There are a couple of examples there on the screen. Something called built-in BSwap or byte swap 32. Just with that function, it's going to go and swap the order of your byte order, right? Where you go your most significant byte first. Or I think it's Java, and just in Java, you do the reverse byte function, and that's how you swap between allocating Big Endian, Little Endian versus Little Endian, or either way. So it works in both ways. The only really tedious thing is that this piece of code that you see here, these two examples, you might have to do that in some of the other dependencies, right? So you might have to do this, address this in a few places. Again, that's only when you're looking at low-level work. I know, many of the engineers, developers working with a lot of this, and they tell me, this is just trivial. I mean, you just have to add the function, test it, it works. But that's really the only piece that it's different for the S390X, unless there are libraries that are very specific to the specific processor architecture. Really, this is the only thing that you have to deal with. And one of the things that we do, and I do as part of my job, is offer bounties. So and one way that people have been trying is also to make a little bit of money here, right? So we offer bounties for porting open source software to the S390X processor architecture. So examples of what we've been doing there, offering these bounties for open source software is in AI libraries, right? Now that there's so much grow on AI related, everything, most of that is Python and all of those frameworks and libraries. Why not porting, making them those multi-platform? Same goes for libraries that relate to cryptography or vectorization math. That's what we've been doing, and there's the link there if you want to take a look. But it's not just here with my role at IBM. I've seen it in other places. So kind of an interesting idea for some of the projects. And again, for me, the recommendation is for your own software to make it multi-architecture, right? And by the way, if you have ideas of potential bounties, let me know. We can also take a look. So I was telling you that I was going to provide you here's the access for an S390X platform. So what is called the Linux One Community Cloud. You can just scan that QR code or go to the link there. And there's other public services, especially for open source projects, right? So there's a SUSE build service. There's an Ubuntu build service you see there. There's a Jenkins service hosted at Oregon State University here in the U.S. on the West Coast, Oregon State University. And there's also the Travis CI service for open source projects. Which, by the way, that obviously you know some of the changes with Travis CI in terms of the credits. I'm told, and I've spoken directly with people from Travis CI. They try to provide as much possible for open source projects. Even if you run out of credits, you just have to contact them, telling them that you're working on an open source project or showing your open source project, and they give you more credits. I've seen it with a couple of people. So not only heard it, I've seen it in action. So that's hopefully a good thing as well, right? To keep some users there on the Travis CI for open source projects. So I'm just going to finish the session with my high level takeaways, and I think you got this right, as the picture says. For me, it's just obviously keep doing your open source. It's a great community. Keep motivated. Keep yourself motivated. I know sometimes, especially if you're a maintainer or a committer, sometimes it might feel overwhelming. Keep doing it. Enjoy it. Enjoy the ride. Obviously, recruit help. Try to grow the community. Be really open there, right? Invite more people to join, not just the small group. And go multi-architecture. That's going to open your horizons, right? That's going to open the potential number of users. There's a lot of people really enthusiastic and excited that are working directly on, for example, on the S390X platform or in ARM processor architecture, that they want to see more software and they're willing to help on making the software multi-platform, right? Again, it's for me, it's all about Linux or any Linux distribution or any architecture. Contribute, go do it upstream, and for the most part, as I've been saying, for the most part, you don't have to really, all the programming languages, compilers, most of the heavy lifting, it's been done. Go and work on your software, and I'm sure you can make it multi-architecture. So with that, I hope I think we still have time for some questions. There's my contact details again, and hopefully one of these days, hopefully soon, we'll see each other on a live on an in-person event. Hopefully really soon. Thank you.
Thank you. So you you answered some of the questions with your last slide, so that was interesting. So this might turn more into a comment, but I guess the availability of ARM has really helped, and also RISC-V to some extent, because now you have all the if clauses in there. The Indianness seems to be the challenge. I like 68K machines, so I face the same issue at times.
I hope I didn't kind of like oversimplify it and make it sound too easy.
No, the devil's in the details. But you showed where the community can get access to these types of machines, because I think that's the most limiting factor. You also mentioned OpenSUSE, but what are the common distros for this type of hardware? What type of packaging is? Yeah,
well, now, a lot of that was on that logos slide. Pretty much all Linux distributions, actually. I know for a fact that, for example, IBM supports Ubuntu, SUSE, and Red Hat Enterprise Linux, right? But pretty much all the other distributions are available, right? Obviously, completely open source. Debian, Alpine, some of the most known distributions are available. The amazing thing is that it's been going on for more than 20 years, right? So not a lot of people know. And then the other question that I get is, well, yeah, but I can't have one of those servers in my garage, right, or my living room. Well, there's now this community cloud. Well, it's been around for some time, that you can access it. Like now everything is it's in the cloud.
Yeah, and I guess then just targeting debs and RPMs and hours, I guess we will have to as well for Arch and those people. You can use these build machines. For the local crowd, I don't know how to see the geographic distribution of the listeners, but for the local crowd, there were a number of episodes in the local podcast podcast called Cod Snack about the IBMs up in the banking sector in Stockholm. So there is a team working on this, and have been for a very long time. So they were more about the COBOL and the assembly, those episodes. But still, it's the same machines still.
Yeah, I mean, amazing in COBOL, for example, that is still pretty strong. There was in the news here in the US when we started the pandemic, a lot of people applying for unemployment, right? And all those government-based systems were using COBOL. And it was big news that there were not enough people with COBOL knowledge. And actually, the Linux Foundation organized a very interesting project with training on different programming languages, including COBOL. And by the way, there's a lot of open source on COBOL now.
Yeah, I think you see a generation shift in COBOL, that people are getting retired or have even to leave retirement because there is no one else to support the systems. So that's one way to get access to this interesting hardware, definitely.
Yeah.
Yeah. But I'm reading the comments, but I don't think I've missed any questions. So unless we have a quick typist, I can repeat the thank yous and the nice talks and so on.
Thank you.
I used to extend my own thanks as well. It's been great having you here. For the rest of the people, this is the last session of the conference days. There is a big-ish add-on thing arranged by the public sector, so the NOSAD workshop, which is listed in the community events page tomorrow. But otherwise, I'd like to thank everyone for attending the conference. Big thanks.
Thank you. Great to be here.